Hello, and welcome to another stream where we work on Kast, the programming language, and gonna start. Let's start the work on the C backend. Let's do that. So let me just write this thing here, right? So currently, Kast transpile Kast as interpreter transpiler let's do this. Kast bootstrap as interpreter transpiler 2.js 95 streak Nigel. Hope Gorley. 95 is a big number. Um current plan is to self-host Kast, is to add bootstrap Kast minicast simpler language in progress. Whip. Minicast JavaScript whip minicast C today working starting today. Do we have like a right arrow like this, right? Kast markup language then when? Yeah. Okay, I'm going to also make this an M dash. I'm not AI though, so maybe I should switch it back to a regular dash. Or people will think that I'm AI. All right. This is good enough description, I guess, right? What's my drink? I have hot chocolate right now, and then I have tea for later also. Not sure how long I'm going to be streaming today. I'm just going to start on this thing, which is the C transpiler, right? So the reason we want to go straight into C because I want to figure out what needs to be designed for the mini cast. We were trying to do like this, like like we was trying to pretend what we are going to transpile the generics into, and I want to be like not too level, but at the same time not too high level language, right? So, yeah, let's go. No distractions from job. Okay, right. So we want. I think like if we can get this to be working, then that would be nice. We also have like this hello world test. Like the thing about the mini cast though is that it actually is only able to target one platform at a time. Unlike the regular cast, we don't have like conditional compilation, but we can like include the files on the command line, right? And we can compile multiple files. By the way, I can do like this over here is 1 b's 2, right? Because I can have number literals already. We don't need to, they have to say native 10. We can just say 10 here. I can make this as 0, and I can print hello world. So right now, this over here is like mini cast to JavaScript, which is able to do like some little simple things. It is able to do the Fibonacci numbers, right? Um, and we do some like context stuff. Yeah, this is an example which is testing a bunch of things, right? So do cast mini compile tests, mini test, and we want to pass this into node, right? And we want to put color false before we do this. That's how we like run this stuff. This is doing a bunch of things, including printing hello world, right? If we can get this example to work on the C backend, that would be nice. We just need to change a couple things, a couple native expressions, right? And the only native expression that we need to change is like this console logging and like toString basically, right? It seems. And I don't know why do we have dbgprint s and dbgprint u here, by the way. That was. Oh, that's because we don't have generics, right? So we have like, yeah, that makes sense. That makes sense. Although I added the any type, so like I can actually do this now in the JavaScript backend without having to write multiple things, right? But this is if we had the monomorphization, but yeah. Anyway, let's start working on the C backend. So, and I'm like, it's going to be very similar to the JavaScript in terms of like generating code. We're just going to generate the types at the same time, but that's not going to be difficult, right? So yeah, but I think we are going to like treat it as a standalone thing. But maybe like later, I will want to actually like look at the code and maybe unify. I don't know if it's worth it. Yeah, we'll see. But right now let's see here. Toki source mini backend JavaScript, right? This has 600 lines of code, so it's like not that much, right? If we can write the C transpiler in 600 lines, that would be good, right? So right now we just have the C runtime, which we were like preparing for like allocating the things on the stack, but we probably don't like use this yet because this is only needed for like the existentialization and like stuff. So yes. How about we do the same? We say that we have the AST, the cast, the CAST, and we have the lib. So what do we want in terms of like API, right? Let's see. So we have the C, and it's going to be a module which includes the AST. And the API looks something like this. we should be able to compile the program. So like the program is what we are constructing in the like general stuff, and once we have the program, we can convert it to the compiled C code, which we can then print. We can also like potentially actually like why am I even doing this? We could potentially just like print things immediately. I'm thinking maybe I'm not sure actually. Maybe not. Right? Maybe not actually. Yeah, let's do it the same way. So we first construct this object representing the C code, and then we print it. Right? Is what we want. So compiled just has the so in JavaScript we just have the top level block because that's how JavaScript works, right? Or we can just like run any code, but in C we need to have like the actual like functions and everything, right? Shouldn't even be like AST called, I don't know. Let's see. So what is the compiled like C stuff? It's probably very similar to my compiled minicast, right? Where we have the types. Um, and then we have the functions, potentially some includes, right? Finally transpile to a real language, yes. Finally. Or should I transpile to a C flavored C++ instead? You think that would be better? Hello, Death Razor. Right, so we're going to have the compile. Compile arguments are going to be something like this, right? So we will have we're going to compile and we're going to give it the target, right? Which is let's just make it a string, right? And we will say that the target by default right now has been JavaScript. Maybe we should not have a default target, you know? I don't know. I mean, maybe later the default target we will see. I don't know. Maybe we should not have the default targets actually. Let's have. I'm just going to parse some command line arguments here. I'm going to say that if we have the target argument, then target is this. Right. Target is none. And then we'll have the target here. So when I run, right? So yeah, in case we're compiling, but this over here is going to be based on the backend, right? Yeah, there we go. So we're going to say that, well, let's first say that target is args target option unwrap or else diagnostic abort specify target, right? Specify compilation target. Okay, so now we have the target, and we're going to say that let's say that target is, if target is equal to JavaScript or target is equal to JS, then it's going to be JavaScript. Otherwise, if target is equal to C, it's going to be C. Otherwise, we're going to say diagnostic, abort, unknown target, escape target, like this, right? And then over here, we are after so this is me compiling to the intermediate like mini Kast representation. And then over here, we do this to the JavaScript. So we do the image target. And if we have over here the JavaScript, then we do this old stuff. Right? And if this is C, then we're going to do something similar, but I guess we don't have like the C runtime. I mean, the JavaScript runtime is probably also going to be embedded in this repository. We'll see. Let's just say this. We're going to say compiled backends C. And that's all, right? So we compile the program and then we print it to the output. And it's just going to be printed to the std out. It's okay. All right. Minicast backend. JavaScript and C. Does Minicast get closures? Yes. But yeah. Let's just do it without the closures for now. Right? Let's just do the hello world. Right, so the question is, how do we represent the compiled C program before I actually print it? We say that we have what? We just have a bunch of functions in C, right? Functions. And this is just going to be like a list of the function. I don't know, maybe it should be like in the AST actually, right? Like AST, like the entire program, like same how I do it in like the minicast. I feel like it's going to be very similar here. Let's say that program is. Let's ignore the types for now and let's just do the functions, right? So we have the functions, which is the list of functions, right? You would add function prototypes as a separate thing. It's a big chance you might need them. Yes, of course. Yes, I think we will like basically write a prototype for every function first, and then we do the implementation of every function. Right? Even although we might like not need the prototype. You know. But yeah. Maybe you're right. Yeah, we have the function protos, right? Which is so just create a list of a function prototype, right? And then we have the actual functions, which is a list of function, right? So what's a function prototype? That's just the specification, right? Which is technically just, I mean, do we care about the order of these things? If we do it like that, probably not, right, at all. But anyway, so we have the function prototype. It has like name, It has args, which is the list of a function argument. Do you specify the types of the names of the arguments in C in the like header files in the prototypes? Like you don't have to, right? But you can. For like readability maybe, right? So we will, I think we will include the names there. So we'll have the function argument, which is basically either which is having the name and has the type. The type is also a thing. And we'll have the type. Yeah, it's gonna hurt. I think you're right. And the type. So we have like some primitive types, right? Like int or void or a pointer to type. Do I need anything else to do the hello world? Well, we can do. We need like a string, right? So what's the definition of a string, by the way? This is like the big one, actually. How do we do the strings in minicast? I feel like the strings of minicast are still going to be not the C strings, right? They're going to be the pointer plus the length, I think. String constants are necessary, yes. Can you do the string constants which contains a byte 0 in C, by the way? Wait, my neobyte is broken, huh? Every string contents contain a 0. Yeah, but like I mean, can we have it like this? Format string contains \0 within. So yeah, like you can do that, right? You can say that char star s is hello /0 world, right? And if I then try to print the s, then this is not going to do anything, right? No, we want like clang source temp c target main c and main c target. Yeah. Okay. Just like checking here, right? We can do it. What about the Unicode? Can you say like Unicode 1, 2, 3, 4, 5? Seems like you can. What's my unicorn emoji again? I'm not a bot. Let me see my unicorn. Where's the hex code? Technical information. There we go. It's 1F right? Okay, there we go. Just like because I don't know if they use the same syntax or not as like Rust or whatever. The \x would be the same. Yeah. Okay, sure. So I mean, what it means though is that, you know, like when I'm saying that we have the constant of type string, we would say like type def struct string, which is having char star content, right? And like size t length, basically, right? And when we want to say this over here, right, we would say that const string s is equal to content is this, and length is and like, so because like we cannot use the strlen in the presence of the 0 characters, right? But we can like calculate it actually. Right? So like 10. I'm not sure. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? I think is the correct number here. But like this is going to be calculated with Kast, I suppose. Like inside, because we have this number. What does strlen return also? Like I would assume that it's like not treating the like it returns the length in the bytes, right? Until the 0. Not the Unicode characters or whatever. That would not make sense, right, for C? And how do you print the string which is like containing zeros potentially? Unicode chars are like this. Well, I mean, this also works. Unless this is like only working in Clang, which I'm using. You think this would not work with like GCC? I think this works with GCC too, this syntax over here. Because U00C0, it allows you on like exactly 4 characters, right? But this can contain anything from like 1 to 6 hex digits, I think. Right? So what do you do? Like write f write chunk of data to stream. There is size and then there's n. Why do we need the size? So it's like it's not the bytes necessarily, but like, why does it not just take the bytes? And also, how do we get the std out? Std out like this, right? This is how we write strings actually, not with printfs, right? We just say as content, as length. This is n, and the size is like 1, which is size of char. The write syscall is using size strings. Yeah, but why? Is there a reason for that, or is that just like historical? Like it just literally just multiplies these things, right? You can also use printf %.s length string. Oh, really? Nice. But we don't need the formatting. I don't think we will need the formatting because the isn't this more expensive because the C runtime must like parse this format string? I literally don't want to parse the format string, right? Because we do that instead of in the Kast standard library. Well, I mean, it depends on what we print, I suppose, right? Like it depends. It depends. But I feel like in the future we will have like, yeah, we'll see. Actually, maybe like to print the number, I could just use this C built-in instead. So this just prints all of that. There we go. And this means that we did not print a new line. F-write can write binary data, and with that you can have different size for the type. Yeah, but like if you write the binary data, could you not just like say size of your data times size of the thing? Or is that like undefined behavior in C? Is that like not exactly guaranteed when you have the array of structs that you want to write? Printf probably gets buffered IO for free. Right. Wait, so you are okay, hold on. So if I say over here, printf, aha, it's not going to be printed. No, it is. Where's the buffering happening? Or is it like happening inside of the file? Printf is buffered, but why is this printed then before the f-write? Or is f-write also flashing the printf buffers? Removes the second printf? It doesn't matter. I mean, maybe f-write is also buffered. I think std out is buffered in general, no? Is it not? Like, you need to actually f-flash the std out, I thought, even if you use the f-write. Is that not correct? Or is that only true for this? Because otherwise, why does this function exist? Right? This function is a possible cancellation point and is therefore not marked with throw. What does that even mean? All right, I don't know any C apparently. Okay. Anyway, let's ignore all these questions, right? That's not the important ones. So we will have the function prototypes, which will have the name of the function, the arguments. I will have the return type, right? And that's all that you need, right? Now the type is like int void. So I feel like we will have to generate like the string type, right? That's why I was going into it. I feel like this is just going to be generated basically, and that's my strings. Right, this way we can have like the substrings and everything too. I see myself changing this in the future anyway, so yeah. I think we will have like, well, it's not going to be like this string. Okay, how about this? Like the generated seed should not know about the strings, right? It should not. We should have the pointer to the type, and we need like, okay, so we need the size t, right? We need the pointer to chars also, right? Char. There we go. Int for the int main, and also void sometimes. Flash might be getting cold when exiting the process. Yes, I'm pretty sure it does. You could test by having F-write and then sleep, then return 0. Let's try sleep. Sleep. 5 seconds. Is that correct, C? I'm just following TCAP's message here. I think that's not correct, though. Sleep. How do you sleep? ISO C99 and later do not support implicit function declarations. F-write will flash on the new line. Is it F-write or is it the printf that which will flash on the new line? I don't think F-write should be flashing because it should not like look at the data actually. Printf, sure, that would make sense. Both. How one sleeps. Oh, it's like this is in the Linux specific. Unix. Time. Is it not like in time? It's like nano sleep. Oh, pause the execution for a number of nanoseconds. See, like you don't sleep in Linux, you nano sleep. Apparently, clock nano sleep. Nano sleep. Requested time remaining. Is that all the documentation there is? Like, what's the hell is the time spec? It's like a struct time val. Oh no. Where am I supposed to get the documentation? How to sleep in C. Sleep function in C. I thought this was actually the sleep function, right? Isn't this just the thing that exists? Include Windows or UniSTD. Right? Shouldn't I just have the sleep there? I think it's just like the yeah. We just sleep for seconds, right? There we go. For 2 seconds. It's just for some reason the LSP did not. Oh, that was loud. Thank you for the gifted sub, Giancalitito. Stream STD error is unbuffered. The stream STD out is line buffered when it points to a terminal. So yeah, it's like the stream itself, right? So it's not the logic of the flashing is not inside of the F-write or is not inside of the printf. It's like buffer. Like where is that even? Is that in C even, or is that in the Linux like in the kernel, that buffering? Yeah. See, it only appears after 2 seconds. That's right. But yeah, they like write immediately. Yeah. All right. Anyway, Void char size t int pointer. That should be enough for now. Program, we have function protos, which is this, and then we have the functions and the function. It's all libc. Okay. So the function is like the same, but it has the body, right? So it's everything from the function product plus the body, which is going to be a block. And we will have the blocks of code in other places too, right? Which will have the well, it just has the statements, which is the list of statement. We will have the statements, and the statements can be the expression statement, which is going to contain expression, and the expression is one of the things is we are going to apply, right, a function which is an expression, and the arguments, which is a list of expressions, right? And that's it. So in order to print hello world, we also need the expression, which is like the literal, the string literal. Or should we... Why does start the hype train every? Why does Twitch start a hype train every time like a single gift sub is added? And it has it like after like 10 minutes after the sub also. Anyway. Do I want to have like the distinction of the place expressions here too? Identifier. So we can refer to the argument of a function. Let's just try to like hard code this for now here. So we will have the program, which has functions, function protos, new empty list. Functions is so it returns int. Is it correct to not return 0 from the main in C? It actually is correct, right? What does it return then? Is it undefined behavior? What do we return in this case? Like, and also, like, and I'm pretty sure it is only true. No, it's like also doesn't complain here for the F. There is a warning, but only for the int F, not for the int main that I don't return a value, right? So weird. Args is return 0 on successful execution. And add the number is an error. Yeah, but what if you don't return anything? Main is special. Like, why does it allow you to not return anything then? It will just close. Well, isn't the exit code, isn't the integer that you return is supposed to be the exit code of your process? Which is supposed, so if you don't return, why is it not undefined behavior then? And like, why is not your process not just returning a random numbers then? That's what I would expect from something like C. It's runtime dependent. Right. Also known as undefined behavior, right? Basically. Well, no, it's not like undefined, right? It's unspecified behavior, a little different. Maybe. Array list. We have no arguments. We'll return this. And we have a body. Let's actually return literal and 0. Isn't it specified? This is from the CV reference. If the return type is compatible with Indian control regions, determining the value return to the environment is the same as if it's executing return 0. Oh, I see. Interesting. But why though? Is it just so that like the developers are so lazy to like write return 0? It like saves a line, so your code becomes shorter. Is that the reason? Because people back in the days were really trying to save on the amount of code you write? Or is there some other reason? I'm just trying to think. Should I like have the place expressions versus expressions, which I mean technically called, or like I mean, so in C this is called like the R values versus L values or whatever, R value expressions versus L value expressions. Do I even care about this when I generate the code? I probably don't, right? We can just say expression, and we will have the expression which is identifier, like this. So we say f is identifier printf, and args is literal string hello world. Right? And this is the function main. So let's just define the printing here. don't have relative imports right now. We need to like dot 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 dot. Okay, ignore some of the things in minicast here. Well, right. No, we don't write. We go over the functions. Let's actually just have the functions for now, right? So we just go for function in program functions iterate, right? And then we just print function. Well, I mean, yeah. Function protos in function proto. Actually, you know what? Like if I have the functions, I already like have the protos of the functions, right? We can just generate this, and then we just write all the protos, right? Like we don't need to store the protos. Do I? I mean, unless it is like linked separately, then I would have to. But otherwise, I already have the information. What's confusing you about the return 0? Nothing is confusing. It's just like weird. For historical reasons. Like, why allow not returning from a function where the function explicitly says that it should return a 0? Should return like a type, right? And it's not void. The order of the function definition is important. You need to define the function because and that's what I mean by I just write all of, basically I go over all the functions twice, and first I define all of the functions, and then I write all of the functions. That's what I'm trying to do here, right? So we will have the definition of every function. How about that? Then I don't need to like generate the protos because we already have it. Void main fate. Void main doesn't work in C. I think void main only works in C++. Or is it? Return type of main is not int. I thought I had an error previously, not a warning even. This is now a warning, but I think it was the GCC. GCC doesn't even produce a warning for this. Yeah, I don't know. You do the same? Yeah. I think it makes sense. So just go for all of the functions. So this means that I do iterate over them after all, right? Function proto of the function, and then I print the actual function. Let's just take the reference, you know? You don't have separate function protocol for external function declarations. Yeah, that's what I was saying, yes. But I don't need that for now. We'll add it when we need it. Right? Okay, so we print the function proto. you think that return functions should always return a default value when return is defined at the end of the function? Return is not defined. Or is that archaic? Yeah, I think that there shouldn't be no like default values. I mean it depends. Like I personally don't like a lot of languages do like these default values for things. Like 0 being the default value, right? Which leads to your pointers having the nulls basically as the default value, but it doesn't like actually it is still not correct data. I am a fan of having the incorrect data being unrepresentable instead, but maybe for a lower level languages like C it does make sense. So I don't have like having the defaults at all, I think. Like by default you should not have the default, if you know what I mean. Unless you specify explicitly that there is a default. Okay, so first we need to print type, which is function result return type. Should I not call it return type? I don't like the name return type. Let's call it result type. Right. Then we write a space, and then we write the function name, and then we write an opening parenthesis, closing parenthesis, semicolon, new line, right? Okay. And we go for arg in function args. Wait. Enumerate. Comma in between. Can you have trailing commas in C, by the way? I don't even know if you can. Can you have a trailing comma over here in modern C? No. Ew. Okay. So then we say print type arg dot type. You can for enums and struct initialization. Can you? Oh wait, I actually do, right? Like over here, I actually did it on like I didn't even think about it, and I added the trailing comma over here, right? So you can do it in the array initializations and the definitions of the enums, but not even in the functions. Why did they not add it here? What's the reason for them not to support it here, but to support it over here? Inconsistent language. Space. Right. Argument. Okay. What's the actual name, right? So we hold on. What's the actual name in C for? So like function proto, is it? It's actually called the proto, or is it called like specification of the function? Right. I just want to reuse this function without the semicolon, I guess, and the new line for the actual function definition. Why would I copy paste this, right? What is this called in C? Proto. So I would not try the semicolon and slash here. I would like do it over here instead. Semicolon slash n. Signature, right? Function signature. You know what? Actually, how about we, instead of saying dot 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 function proto, let's have this function signature. And over here, the function itself is going to have the signature plus the body, right? There we go. Right, so we'll go over the function and we'll print the function signature, function signature, and then we print the function, right? There you go. So when I print the function, this would be not the function, this would be the signature instead. So when I print the function, if the first thing that I do is I print the signature of the function, it's okay. I can write out the full name here, right? And then I like shorten the fn. Should we like write the functions that have fn's? I'm a little inconsistent with which words I shorten and which words I don't. What do you guys like more? Should I say that this is a function? Signature. Write the space opening curly bracket. No, we just write space. And then we just print the block, which is function body, right? And then we print the block, which is block. This is the thing that writes the curly bracket slash n, increases indentation and decreases indentation, and writes this thing. And then over here for statement in block statements. Great. Print statement. Write slash n. Or should printing the statement include the colon? How do I do it in JavaScript, I guess, is the question. Yeah, we don't include it. So just do like that. And then we print, let's move the function signature here, print statement. All right, so right now we just have the single expression statement. Well, I mean, we will have to do the return, by the way, right? Return is not an expression, so we need to return expression, right? So expression, in this case, we just print expression. If we have the return expression, then we write return, and then we print expression. How about this? Say right. Punctuation. Right. Do colored output, because why not? Right? Why not? Let's get rid of these things. I just say instead of output right. And mostly just writing punctuation. But the keyword over here is going to be the keyword, and we will just like color it. Have you ever looked into Odin or Zig? Yes, I did. I did write a little bit of Zig. I did not write any Odin, but I did look into it. They're okay languages, I guess, if you like low-level stuff. I prefer high-level programming. I don't want to think about low-level details too much usually. So I prefer a language which like lets you go into the low level, but at the same time lets you go into the high level, right? So I want a language that is both low and high level, which is what Rust is basically. Out of those two, I think I like Zig more, but I'm not sure. Zig is obviously like most famous for its compile time evaluation, and yeah, I would say that the things that they have implemented in Zig are implemented pretty well, but it's just not enough for me. Right. And like the reason I've been writing, I've never really like I try to write as little C and C++ back in the day too, because I don't know, maybe it's a skill issue, but I never figured out how to debug my segfaults properly. It's always a pain, and from what I have heard, it's always a pain even if you know how to use the tools. I mean, yeah, I've spent some times with like Valgrind and stuff, but it's just easier if you like if the language doesn't allow these issues to happen, you know. I don't want to think about how do I not shoot myself in the foot while writing code. I want to think about the program logic, you know? Like people think that the lifetime annotations in Rust are preventing you from thinking about it. I don't think about lifetimes when writing Rust, okay? But when I write C, yes, that's when I do think about them, because like the compiler doesn't think about them, I have to think about them. You debug C by spamming logs? Yeah, but like not everything can be caught by logs, especially like in a multi-threaded program. right? When your bug is because of the race conditions and stuff. Do like C++ only works well if you use IDE like CLine? I don't know. What's the problem with debugging in VS Code? Isn't that the same debugger under the hood anyway? Like you use like LLDB or whatever, or GDB? I mean, you can use those in the terminal too. How will I do my memory management? Defer external GC. I'm going to have the RAI. Like the memory model, then like the memory management is supposed to be similar to the Rust, right? So we want the borrow checker, we want RAI, right? Which is similar to defer, but not exactly defer, right? Because there was supposed to be like the move semantics and stuff also. Which is why I'm like I was trying to like not get into the C transpiling for as long as possible, and why I was doing the JavaScript, because I'm afraid that my current code, when I transpile it to C, will actually not adhere to the borrow checker, which I have not implemented yet, and we will actually have undefined behavior and like use after freeze after when I compile this to C, like when I actually do the transpiling of the existing code into C. Bum, 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 ba-da-dum, bum. All right. Okay. Also, by the way, over here, I just like to capture this by reference. We are going to surround every expression with parentheses, even though it's not necessary. Maybe later we will like figure out how to not do that. But for now, we're just going to say like write punctuation, the opening parentheses and the closing parentheses, and we will actually write the expression inside here. Right, and the expression, we just have the identifier, in which case we just write identifier. Just rename write punct to write. It's just writing without any color. You could do something like Boehm GC for memory management. I don't remember. Like, is there like there was people who were pointing me to the C. I don't want to do the garbage collection is not what I want to do in the end. Okay, we are using it as the intermediate like steps while I'm implementing the language, but in the future I want something like Rust, where garbage collection is opt-in. Like it's basically like you would be able to say like GCT explicitly if you want garbage collection. Otherwise, you have like the regular semantics, right? The garbage collection, reference counting, or like other things, right? There was like this thing which allows you to like run the C code with the runtime checks and everything, where you don't have any like undefined behavior and stuff. If anyone remembers the name, was it the field C maybe? Phonetically compatible memory safe implementation of C and C++. Maybe this is the one. And this one like is basically yeah, like it's supposed to like run your C++ without with zero changes, and this one does have like the garbage collector. Does this mean that I can return the references to like local variables actually in this one? I don't know. Maybe we like I still like want eventually to like produce the correct C code with like correct lifetimes. We will have the borrow checker and stuff, but in the meantime, we can use this. Right? Or whatever. It's possible to run a totally memory safe Linux userland instead, including GUI with VLC. Whatever that means. Right name. Will Kast lifetimes be as pedantic as Rust lifetimes? Well, my idea is based on the Rust, so I think so, yes. But the what do you mean by pedantic? Do you mean like verbose? Where you have it everywhere? I think one of the advantages of Kast, maybe, is that we can have the generic argument on like anything, including the whole modules. So you don't need to like do the lifetime annotation on everything, you know, like lifetime here and lifetime there, right? You can just put this single lifetime like over here, you know, and then everything inside of this module depends on this lifetime or something. Especially like when you use like arena allocators or something. I think that something like that would probably make sense. Is this how we get performance? Produce unsafe code? Exactly. We produce unsafe code, but like I was just saying, welcome us code. I know about like this thing which is field C, which is a memory safe implementation of the C and C++. You already know and love. We all love C and C++, right? Right? Apply. Forms. Field C adds a garbage collector. Yeah, I know. I know. Wait, so you're actually familiar with it, right? Does field C allow me to return the references to local variables? Right? Is that so? Like it adds garbage collect. So instead of like panicking when we when we would have like a use after free, instead of that, they just let the values to live for longer, right? Via the garbage collector. Basically, same as the Go language does. And they probably like do some escape analysis to see what needs to be garbage collected and what's not. What do you mean is, are there other ways of managing object lifetime? What do you mean managing object lifetimes? Do you manage the object lifetimes in Rust? You check the lifetimes, right? There's a borrow checker. It will trap at runtime if you do that. So what's the garbage collection is for then? Golang depends on the memory unsafe C libraries. Field C is on the way to syscall safe. That's what the guy said. Kernel itself isn't safe. Only the parts are written in Rust. Does the Rust code that is in the Linux kernel not having any unsafe code? Tons of unsafe code. Other ways of preventing use after free at compile time. Then the borrow checker? Well, I mean, yes. You can use, I mean, same as in Rust. You can in Rust prevent use after free, not only using the lifetimes, but also using the reference counting or using garbage collector. There are garbage collector crates for Rust too, right? You can do that. Anytime it interacts with the internal C APIs in the kernel, allocates the memory, interacts with MIO, and it's doing unsafe. Right, but like, is there any unsafe in like it wraps those in safe abstractions? Yeah, there we go. That's what I would. I mean, obviously you have to do the unsafe to write the FFI, right? And then you wrap those in safe abstractions as soon as possible to minimize the amount of unsafe code. That's the correct way to do Rust, right? Right, opening parentheses, right, closing parentheses. for iarg and args rate enumerate if I is not 0 right comma expression arg. I think I'm done here. If this compiles, we can see the hello world. I'm not compiling my minicast though, right? I'm just like, I've just generated the AST for the hello world. And then the next step would be like actually compiling. GC and ref counting has overheads. You mean the same kind of object unlock deunlock as Rust auto does, but without lifetime subtyping and borrow checker? Well, if you don't check the borrows, then how do you... You need to do some kind of borrow checking. It doesn't have to be like exactly the same borrow checker as in Rust, I suppose. There are other alternatives out there. But from what I've seen, they all are not as good as the Rust solution. If you want runtime memory safety, then you should write your own GC instead of using field C. I control what and how it is compiled. You can do much better than field C. I mean, yeah, maybe. But like, yeah. I just feel like we want something. Well, I know that there's like while grind and stuff, right? But we basically want to like, I mean, yeah, I can like generate this code myself, but like if there is a tool that already does this for me to like see if my C code is actually like properly memory safe, easier, right? Then like that's less work that I need to do. Isn't the guy compiler engineer though? Who? Me? No. I know nothing. Oh, you mean like the field C guy? The short C lang. Field C has to contend with the entire C language. Kast does not. Yeah, that's right. Okay, we have the function is not there. Wait, program functions is not there. Program functions. Program. Oh, it's a dot. I'm stupid. This should not compile. I should have seen a different error. Field type is not there. Print type. Yeah, right. I need to print the type too. Print type. We just match the type, right? We have the void. Then we write keyword void. Then we have int. And we write keyword int. And we have a pointer to t. And we write a star after this, right? Right. Print type t. Have you seen this? The Rust for Linux pin init macros. No, I don't think so. This macro first parses the struct definition such that it separates pinned and not pinned fields. Afterwards, it declares the struct and implements the pinned data trait safely. Dun, dun, dun. Now we use token munching to iterate through all of the fields. Oh my god. Look what they have to do to mimic the fraction of the... Yeah, I don't like I don't like the way macros work in Rust, and like, yeah. This is monstrosity, right? But what does it actually do? It like passes the separates the pinned and not pinned fields. What's a pinned field? Like the field which has the type like pin t or whatever. So you, and like the way you do it in Rust, you say like this over here is pinned, right? And is pinned is like literally looking at the symbol, because you only have the token information here. Yeah. If some value needs to be initialized in place. Oh, some values have to be initialized in place, and some values can be initialized other elsewhere and then like moved into this thing, right? Yeah, I see. I see. Boop, 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 boom. Yeah, I think like yeah, it must be. I think they're like the in place construction is also like interesting thing, and I do have like a rough plan of what I want to do here, and I think we just make it like basically closer to C, but like different. I don't know if I have been talking about this before, right? But basically, you, instead of saying box new thing or whatever, right? You need to basically, so like this semantically construct this first and then does the boxing, right? So it allocates the memory after constructing the object semantically in Rust, right? And then you just rely on the optimizations for this to be the in-place construction. So what instead I think we want is we want like box. We want to basically allocate the data, and we like return the we have like the place basically, right? And then we say like place, like, and then we like initialize the value in place. So like basically it's same how you do it in C. You would just literally say like malloc, whatever, right? Right. So like the thing is this, and then you like initialize it field by field or whatever. But you like make it type safe, and in order to make this type safe, like this return type must be like the out pointer, which would have to be initialized, which means that the language must support like linear types and stuff, because just the affine type system that Rust has is not enough, because we must guarantee that this has been used and stuff, you know. But yeah, all of this is like far in the future, I think, still. But I do have some ideas. Is this how you do the pointer, right? You type the type and then you put the star, right? Pretty sure that's how you do it. What else we have? Char and size t. Also, if I remember correctly, especially like if we talk about this here, the star is not part of the type, but it's part of the like of the variable, right? But for the sake of code generation, we can treat it as part of the type, right? Unless we use the same type for declaring multiple variables, which we will never do, basically, right? I didn't add arrays. I don't need them yet. I'm trying to do hello world. I'm not even compiling anything. I mean, I've just generated the AST. I want to print it on the screen. Pointers are all you need. Well, I mean, yeah. Pointers are all you need, I suppose. Oh, we don't have the function protos anymore. We only have the functions. How does this not compile still? Function is not name argument result. Name args result type and body. Wait, what is the function? Oh, right, because we have the signature, right? We have the signature, which is this, and then we have the body. Statement is not apply. That's right. So this is not a statement. This is an expression. Apply. Right. Can you compile already, please? Expression is not literal. Oh, yes. So we need to have the literals also. We need to have expressions, which are literals. Right. Let's have the literal. We'll have the int. We'll have the string. Let's have the char. The char, the C char is not the char of the minicast though, because this is the UTF, the Unicode code point, and this is just a byte, right? You cannot have in C the char to be this full thing, right? I guess we'll have to like check that this is, and Kast doesn't have U8. I think we like just like panic if we try to do this. Or I guess we just let this C to detect this as an error. It's okay. Just put the char here because we're just going to like put the like slash ends and stuff there anyway. It's okay, right? It's okay. Any other literals that you need in C? Probably not. I guess for the literals we don't need the parentheses. Let's save a little bit on parentheses here. We just try to use the cast escaping rules. It's probably should work well enough here, right? Wait, what do I write for the C? How do I escape a single character? Do I have that? I'm not sure if I have that. Let's open the bootstrap. Do I have the escape? No. String. Should have like this code to be extracted, right? Like, does this need to be escaped and stuff? We can escape. Okay, here's what we can do. We can cheat here. We can say string escape contents of the two strings C. Yeah, we can do that. Because to escape contents has the delimiter. Yeah. I think this is also not the very most efficient implementation there, but that's okay. We have the delimiter be the this, right? And then we write this before and after. All right. Are you ready for the hello world? Task mini compile. What do we compile? It doesn't matter what I compile, actually. Tests mini hello. Let's write the hello. Let's write hello C. Like, how would we actually want to have this, right? We will have the main, which is a function. Main should probably actually return the integer, now that I think about it. In minicast too, right? I mean, and this would like translate to the void. Seg false. Yeah. I mean, the simplest one, we just have the native expression here, right? Which is like printf. Hello world. I mean, this is the simplest one, and then we need to actually have a function or something. Anyway, we don't even parse this right now, right? So, okay, so we need to compile target C. No such file or directory. I should call it hello C. Okay, there we go. Look at this, beautiful. Is this like correct? The code? I also probably want, after I print a function, to write the new line, right? Yep. Like this. Okay, and then we can I just pass this somewhere? Let's have it in the just file, actually. Let's have something like C, just C is going to be cast mini compile target is C, and over here we have the path, right? we do the path. And we put this in, and we do like color false, and we put this into target compiled.c, right? And then we like do clang target compiled c output target compiled, right? And then we just like target compiled like this, right? Which means that we also need to install clang here. Let's put the clang over here somewhere. We just do clang, right? Clang D. That's I also figured out why I was not doing this. Yeah, I needed to export like the clang D flags because by default clang D only works if you have like CMake or something, and we don't have that. Wait, isn't clang D not even installed here? How was this working? Huh? Is it already part of the clang? I think I just need to do this, right? What is this? No! Why is there some output here? It's not supposed to be there, is it? Yeah. Clang D. Clang D is just installed with the C-lang, it seems, right? There we go. So we just want just C test mini hello C, right? Like this. Okay, so it says that we need to include the header stdio.h, right? Because we forgot to do this. So we need a way actually to tell this thing that we need to include certain things, right? How would I know that we need to include something? So right now the way we talk to the like backend is through the native, and the natives are always expressions currently. But we can like do some magic, like I would have like a native expression, I guess, which would just be the, we can do like the hashtag include, I guess. And this obviously is not an expression, and we would like put this into the beginning, and it doesn't matter where you put it, I guess. It just adds an include, right? Include std io.h is what we want, right? You think it has to be at the top? You think in the mini cast we should like have basically the native way to like, the problem though is how do I do it in the regular cast, you know? I think it should be able to be anywhere, right? Like, and we would also like specify what we do we need to link with in the similar way, right? Just put it anywhere, and it like adds the stuff. I mean, I can like make this to be at the top, but then in the regular cast, how do I decide if I put this thing at the top or like inside? Then it means that the native expressions in the regular cast should be like, there should be like a native expression versus like a native like way to tell something to the compiler. Rust definitely asks you to have it at the top. The includes? I mean, Rust doesn't do the includes, right? In Rust, you do what? Like the linker? I mean, there are some attributes in Rust that you have to put at the top, right? Like, for example, the like Windows subsystem windows or whatever, right? I think that has to be like at the binary crate top level. But whenever you want to specify what you want to link with, yeah. Like, I feel like having just a single way to talk to the backend instead of having multiple ways, I don't know if it's better or not, actually. I don't know. Let's just do this for now. I think that's okay. So the way, I mean, we don't do any like processing of this anyway for now, but what we want is in the C backend, we want the program to have this, the includes, right? So we want to have the includes, which is a list of strings, right? Just like that. And when we print the program, just say for I borrow check wants to collaborate. Are you streaming right now? What do you want to talk about? Hello? I'm not sure if this is going to work even, but I mean, sure, let me accept this and see if it works even. Hello?
Shut up, music. Ooh, look, chat, look at that gooey ones over there. Oh, used to eat Kast. Not a really good stuff going on up until 10 a.m. Then
I cannot
bed.
turn the mic on. I can click turn the mic on. Hello?
Ooh, look at him. Yay.
And select it maybe
Look at it.
first.
It's gooey one.
There we go. Yo,
The man of the Kast.
you hear me? Do
Yeah, I
you
can hear
hear
you.
me? Okay. What did you want? Hello? Welcome.
Very nice.
Do you want to talk about the C and how I'm doing everything wrong?
Hold on, my one ear is blocked. Oh, I need to get closer. Let me put on my headphones so I can hear you. On your headphones. It's gonna block me the other ones. Wait. Oh yes, I can hear you now. Very cool. Now we're talking.
So what
What was
did
it?
you
What
want
was
to
it
talk
that you
about
wanted?
something? Hello, hello, hello. Why are you? I have never done a
Oh, we're
collaboration
both streaming.
before, but
Same. So this is like a first time. I mean, it's nice to see one and two do
let me also
stuff.
mute the
I saw you were streaming, so I was like,
headphones.
ooh,
Hold
I'm
on,
gonna see what they're
so I can
doing.
hear you better. All
What even
right.
is a Twitch collab? I don't know.
It means that we talk to each other and like you know,
Ah.
which means that you wanted to talk about something. I'm assuming, right? Since you clicked the
Oh yeah,
button to collaborate.
yeah. So remember during the day we talked about the operator stuff?
You want to talk about the syntax? Okay.
Yeah, I did actually the change, but I decided I went to the colon equals for definition and binding, and the uh, single equals for just equality.
Talking to people on stream is a little bit awkward. I usually don't like talk to people. um, it's hard for me to focus on what you're saying. You know what I mean?
It's fair.
Um,
One thing, single
okay,
threaded.
okay, so you use the single equal sign for equality. Okay, sure.
Yeah.
So the C programmers are going to hate your programming language because that's not what they're familiar with.
C C programmers hate anyone and everything. They
Well,
make
they
their own
they,
stuff.
they
They
love
never
C.
really use anything else.
They love C. Talking period is awkward. I love being a bunch of text in chat, says Nigel. Yeah. I don't know. I feel like when when I am on other people's streams, like even talking in chat is a little awkward. I don't do that either.
Single equal is evil. Come on, dude. Double equals is evil. Just look at what JavaScript did. Triple equals. That's funny. That's circus. Now that is evil. JavaScript is more evil than C, and JavaScript is borrowing from C. The same array problem. I'm drinking Gola.
All right. So what did you want to discuss? I feel like I want to like make progress on C. Let's discuss this syntax for a little bit. That's okay, but I don't know. It's becoming more and more awkward every second for me. I'm being
So
stressed
you want
out
to
by
stop or
the.
something?
I'm being like, you know, Pro Checker is sleep deprived. Right.
Yeah.
So what
So you want
about
to
the
stop?
equal operator? What did you want to talk about there?
Well, we talked about yours, right? You said something about the other side arrow and the dollar sign
Yeah,
for the
I like for
assignment
I
operator.
would like ideally the arrows to be symmetrical, right? I mean in like in general in the terms of like syntax, if you think like if you look at the bunch of different syntaxes in languages, the and like the decisions that language make, like the most important decisions are basically prefix versus postfix, right? So for example, when you take a reference or like when you dereference in C, it's a prefix operator, right? You say like star pointer, but then like it is pretty awkward in a lot of places. So thing like Zig, for example, does pointer dot star, right? Odin does pointer caret and like things like that. But the most important distinction is postfix versus prefix, basically, right? And same goes about things like await something in languages like JavaScript or I don't know C# and other ones, right? Versus in Rust, you say something dot await, right? And the same goes about I don't know, calling a function, right? You say like you say function and then you say arguments, or you can say arguments and then you pipe into the function, right? So like basically you want sometimes one direction and sometimes the other, and a lot of the syntax in a lot of languages that only allows you to write something in a single direction, right? So when you think about the syntax of anything, basically, I think that it's important to think how you would do it in the other directions. So if you like using the arrow syntax for like assigning things, right? So you have like place and you assign the new value into the place, right? Then like it naturally can go in the other direction, and you say like value, and then you put it into the place like this, right?
Hmm.
You know what I mean?
Yeah.
It's
The
just a
thing you
little bit
brought about the
unfortunate that this
pointer
arrow
syntax.
in math means like usually. Well, I mean, I don't know if it's actually math or is it like the functional languages that invented the syntax, where the right arrow is like the function type. Is that math actually,
That
or
no, I think that's type theory specific function typing, like a curring type function typing system. It's something mathematics,
well,
something
I don't know.
theoretical.
Is it like part of the type theory maybe, which is technically part of the
It
like
is.
math? Then right?
Yeah, it's part of type theory.
Yeah. So like that's a little bit unfortunate then, though, right? But hello, Ray March. Ray March still loves talking about syntax,
Hello, Ray March.
right? I just repeated what I talked to you like that other time, right?
Yeah, the C pointer and the multiplication syntax. Yeah, that's the problem with the prefix and postfix. Prefix unary and postfix unary. It's like overloaded. The Zeek does it right. I would say Zeek does it partially right, especially the one where you access the pointer with the postfix dot uh, star. That one's good.
Odin does the carriage just like Kast does. It's Zik is doing the dot star.
Yeah, but they're still overloading it with the prefix and yeah, that's still a bit confusing, especially if you have multiplication and the pointer at the same time. You have to use parentheses, but then it's also confusing. Like, why would you have to do that? That's unnecessary.
There is no overloading of that the in Zig or Odin. And I think even in C is technically like pretty like, because in C you never do the function application without parentheses, like because it's not a functional language, so there is still no ambiguity really, I think. Okay, hold on. I'm adding to my function to have the include the stdio. Yeah, you can also use emojis. Did you think about that? There's so much emojis. Why you limit yourself to the emojis and like Unicode in general, right? Why limit yourself to the ASCII stuff?
Are we going into Objective C now?
Is Objective C doing that?
Yeah, and so does Swift.
Wait, what? Swift Unicode operators. There's no way.
Okay, maybe not operators, but
But it,
Objective C lets you use a lot of emojis on a lot of things.
Swift allows you to define custom operators. Yeah, I remember that, right? You have the custom operator, and then you can, yeah, but like not in the standard syntax though. If you extend it, yes, and then you can use the Unicode for like the identifiers. That's a lot of languages to allow
I,
you include.
Oh, when it comes to custom operators, I also added a similar system with called infix L, infix, and infix R for like custom like long operators. I thought that it might be a good idea, so you can define precedents with a numeric, and then you can add like this specific operator with the parents. James Swift. Oh God.
Yeah, remember Swift has the custom like syntax thing where you can define the priorities. Kind of like similar to extending the syntax in Kast, even although it only allows you for having the custom operators and not like full custom syntax. But it's kind of similar actually. Yeah, I don't mind the users being able to add the custom operators which are not ASCII. I think that's actually cool that people can do that. I would not do that myself though. The ligatures are enough.
I myself don't allow users to use unique code in identifiers.
Does Linkstar support 120 FPS? Yes. I'm developing it on 140 FPS. 144. 2K monitor is what I have.
What panel?
Huh?
What panel? Is it a mini LED, OLED, TN, VA?
I have no idea. How do I check?
You Google the model.
How do I look at the model? It only says Samsung. Is
On the
Samsung
back.
bad or good?
No. Samsung's not bad.
German 1HD. Hello.
Let naive Bezier. Ugh. Unicode identifiers. Ew.
All right. If it's okay though, I feel a little weird being in the call. I would like to focus on Kast. All right.
All right.
Yeah. Thanks for calling
That was
though.
a good one. Yeah.
This is making Kubi unproductive. Like I was productive before the call. um. This is a string, and I have a reference here. I can also buy a nose color nurse display with the hood on the edges. Wait, can I not like say something like fast fetch? Does this tell me the monitors? Yeah, I have this. This is the model over there. 2K, 32 inches, 144 hertz. Let's take a look. It's a W. Wait, does that say VA? W LED. Is that correct? Is that bad or is that good? What's good or what's bad? I have no idea. This is the one that I have. 5 kilograms. VAW LED. I don't know anything about the displays and what's good and what's not. Feels okay. Is VA monitor good? Well, now we are distracted. It's generally excellent for general use, media consumption, and immersive gaming. Right? So it's actually the good one. Are VA panels really that bad, like the second thing? So it's a good one. Hello world. Look at this. We have the hello world. Hold on. So first thing that I see is that we don't have the new line after the include. So let's fix that. Is that the only warning? Right? And we can like print it with colors on the terminal like this too. I think maybe we can have like an empty line between the includes and between like the signatures like this, because why not, right? All right, so the next step is actually like transforming the mini cast into this. So we need to compile the program, right? The program of the minicast already has the things, which is called functions. So this is just like name and function definition. We have args. Yeah. Let's do stuff here. I will commit this anyway, right? C is T for hello world. Okay. We'll cast cheat output from Lua. Well, we're supposed to ahead of time compile. Well, I mean, the JIT maybe will also be there because we have the interpreter, which I would want to JIT. I think it should be output from in Lua, right? Because we have more type information, so we can like compile more efficiently. But that's in theory. Right now, Kast is really slow. Catalyst will end Lua as a game scripting language. I think like I'm definitely not targeting the like small size though, which is what Lua is good at, right? More typing for a slow compilation. Well, not necessarily, because you can skip the types on like you can have the JIT to be multi-stage, right? And you can start by compiling it. You basically just start by interpreting, then like you compile in the background. You compile it like not very efficiently, then you compile more and more efficiently in the background. Right? Isn't that how it's supposed to work? Do the existing JIT engines, like for JavaScript, for Lua, just compile everything once, or do they have like multiple levels of optimizations? Well, you need to like process the types. You need to do the type checking, right? But as I understand, like the existing JITs in Lua and JavaScript, is that like basically they need to detect the types a lot of the time. So, and we already have that information, so it's actually going to be faster, right? Because of that. You can run C++ in a REPL, so you should be able to make Kast fast. Well, being able to run C++ in a REPL does mean that it runs fast in a REPL, right? But it probably does, right? Yeah. Because I already can run Kast in a REPL, but that is slow. Because that is just using the interpreter, which is just the regular interpreter that swocks the AST, I guess. Okay, so we delete all of this code that I just did, right? Instead, we basically We don't mutate. Wait, why am I even mutating this program? That makes no sense, right? We instead say that we have the compiled, right? We say that not result is. So this is like the AST, the CAST program, right? So we will have the includes. We'll have the functions. That's it, right? So just go for function in program functions. Why is my Kuvi bot like joins the chat all the time? Can you take a look what's happening there? What is this? Connection was closed. Who closed the connection? Will Kast JIT outperform Lure and then the connection was closed? Raymarch. Killed my bot somehow. What about the previous death of the bot? It was Nigel. Is it just Twitch closing the connection? Who is closing the connection? That's weird. All right, so we have the program functions. This gives me the name and definition of the function. Right? So this over here, we just need to say that. I want to like have the context here. Context. Is context. Context. Guess I actually do this. Right. Just say with context. Beam. Program. Result. What's that? And then we return the context result. That's what we return in the end. Result. Right. So over here we just add function name definition. That. Get rid of that. Okay. So we say like add function, right? So this would be the name of the function, the definition of the function, which is the function definition, like that. Okay. So we just want into the result. To add the function, right? So we want to construct the function, right? This would be like AST function. Definition. No, we don't. We want signature and we want the body, right? So the signature is going to be the name is name. The arguments is just have the args outside. Right, we also go for arg in definition args. Iterate here. Also, by the way, this by the way has key and value, right? So this will be a reference. With the argument args push back argument. So argument is the do you go to function arg? I do, right? You need to have a name, argument name, and I'm going to have type, and this is going to be like, it's going to be able to convert type of the argument type. And that's my signature. And result type is a function. Result type is definition result type. Convert type. Convert type is the function that takes the type from this and returns this type. Okay. So this is where we just match the type. So here's all the types that we currently have in the minicast. So we have the any, which is going to be the void, but we only are supposed to be able to convert the void stars, right? But let's say that this is void. We only should be able to have it behind the reference though, right? The unit is the actual void. Although we cannot have a variable of type void, right? So it's a little bit weird. Unwind token list and ref. Yeah, we don't know how to do this yet. Well, I mean, we don't have to do all of these yet, actually. You have in C something like actually you actually have the type like int 32t, right? To be more specific about the byte size. I probably want to have like an actual int size though in Kast, I'm pretty sure, which is like less specific. Right? But since I call this int 32, let's do that. Sure, int 64 and 32, load 64. This is also going to be boolean. Yeah, booleans we also need. We need chars. So the question is, how do we do the strings, and how do we do named? Named would be the named, right? Still. Even there. And function, let's just have it as a to-do for now. Let's have a string as a to-do too. Let's just have a reference to be, so reference are just pointers to converted types. Right? And then we need the body. So the body, so this needs to be a block. Yep. And then we need to return, right? So body is a block. We need to create a new block. We need to say that I will have the block, or we will actually have the scope. Block is block. I might have the other things here. Similar to how do we do this in the JavaScript? Scope, context, block, reference to AST block. Let's do this for now. And then over here we want to, so the way we do it, because I like minikast is expression based, we want to like calculate expressions, and this stores the result in a variable basically. So this would be definition body. We store this in a variable, and then I like return it, right? Insert statement, return result is this, return result. By the way, is in C, but it can also be a single statement. Yes. Well, I mean, yeah, we don't have to do the return, right? I guess like because like we don't return on the void types, we need to see if the type is void, then I don't need to do this, right? Yeah. Also, my question is C evaluation order, is it specified or not? Is it undefined behavior in the C language? General rule, unspecified order, right? In most cases, we don't specify. So when you do a call like this, whether A or B runs first is entirely up to the compiler, right? We don't want that, I think. I mean, at least like until much later, when we have the proper side effect inference system, where we can reorder things, like then we do this thing. But for now, we want the correct order. So, which is why the calculate is the stuff that actually does the calculation and returns, like, I think this should be like returning the pure expression. In my JavaScript transpiler right now, this just returns the reference to a variable, so I always store it in a variable. But maybe we can just say that maybe if some things can just be pure, and I can like get rid of some unnecessary variables. Not that it like matters much, but well, in case of a return, it does not have to be pure, I guess. But like for the general stuff, I mean, we can also like start with the same I'm doing in JavaScript instead of like thinking about this. We start with something that works first, right? And then we do something, because like even yeah, let's actually do it the same way. The optimizer will rewrite everything anyway. Yes. So we just say like identifier result. So calculate returns the identifier. So we say calculate. This just has expression, and this returns the identifier. We could make it more typed than just a string. Actually, how about we make it more typed than a string? So that way we guarantee that it's a correct C identifier when necessary, right? Yeah, every time we do a name, it should not be a string, it should be like identifier. And this identifier is also identifier, right? And then we have the identifier is a new type, which just contains a string inside, right? Sure. Or we can name it. It's okay. So when I write the function signature, I want to write name, signature name, and we write name, arg name, and when we do the identifier, write name, right? And when we write name, wait, I called it identifier. What do I call write name? Write identifier, right? And we write identifier name. Right. So this name is going to be identifier name. This is going to be identifier arg name. So we will have the function called identifier, which takes the name string and returns the identifier, which we will for now just say the name, but we will like to do make sure it's a valid C identifier, right? Because that's not necessarily the case, especially if you use the row identifiers in Kast. Okay. So we calculate this returns actually the identifier, right? And this is my result. Okay. So we need to calculate. We also need to be able to insert statement. This takes statement. And what this does is it does it into the current scope. We have the statements and we push back the statement there. Okay. Calculate. All right, let's see now. How do we calculate? We need to match expression. We have expression shape here because we have the types available to us. Right, so here's all of the expressions that we currently have. Dun, 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 dun. Okay, let's see the important ones that we need for the hello world, right? How about we start by commenting everything and we start with applying because that's what we need. We need to apply a function, right? Also, we need a, yeah, I guess we also will need a statement. Now that I think about it, to apply function and args, right? So we say that f is calculate the function. We will want to so we will want to let variable name let expression that we use to actually do the calculation here is going to be something. Then we will need to say variable, new variable, value, let var expression, and we will need to specify the type of it, right? So the type is going to be convert type expression type var, and then we return the var. New var. So this is like name prefix. We want to create a new unique variable here. Right? Which means that in the context, I will have like next, we just have the ID, whatever. Next ID is 0. Pum, pum, pum. Ident. Identifier is identifier. Name prefix plus to string context next ID. Identifier. What's with the different camera setup today? I don't know. I just moved the camera. I moved it not today. I moved it like a couple days ago. Originally because the sun was shining into the camera, and then it just stayed down there. Current scope. Oh, this should like have block statements, right? We have the block inside of the scope. Yeah. All right, we need the let var, right? Okay, so I do need to like have a statement which, so like we have this statement which initializes a variable, right? So let var would be the type, and this would be like AST type already, I suppose. Or should I give it like the original type? I don't know, let's give it the original type. Right, and then the ident ident xt ident, and the expression is AST expression. So this would just insert the statement where so we need a new statement, which is like let var, right? Type is convert type identifier expression. There we go. That's all we need. Is minicast actual subset of cast, or is it entirely different? I guess it is like one of the things that I don't have in cast, but I have in minicast is the unions, and like, yeah, I have like, I don't have the unions there because in the regular cast we have the sum types, which is tagged unions instead. But because, yeah, I was actually like thinking that I'm not sure if I want this to be in minicast or not. Like, it's basically I'm basing it based on like the things that I'm targeting, I guess. So yeah, we have the untagged unions, right? Like in C. Well, I mean, cast is representing the tagged unions as a pair of a tag plus the value, and the value is the untagged union, right? So we that's already like implemented in the transpiler from cast to minicast, basically. Because basically in all of my backends that I'm planning to target so far, none of them have the tagged unions anyway, right? So JavaScript doesn't have that, C doesn't have that. Yeah. If I was like targeting some like higher level language, then maybe that would make sense. But I don't so far. What if mini C was to exist? That would be B. Okay, we have insert statement. Yeah, we need to have a new kind of statement which is called a let var, right? Which has the type, the identifier. So we only allow like a single variable, not multiple variables, and the value, and the value will be expression, right? So when we print the statement here, if we have the let var fire I should already like make the shorthand syntax for the field by reference. So for this, what we do, we print the type, and then we write a space, and then we print identifier, which we should do instead of the write and then write print ident. We print identifier. Identifier, and then we write an equal sign, and we print expression value. Okay. All right, now I don't remember what I still need. So let's see. Context is not found. Oh wait, do I actually need this to be like used after the context? That's a little weird. I thought this is supposed to work, but okay. Oops. Most popular language in pop culture in C++? In pop culture? AST type is not void. Oh yes, we need to have the named types in the C, right? Well, I don't need that right now. Can add that later, but we will have it anyway, right? I can add it immediately here. Named. So named would be an identifier, by the way, right? Ident name. Named print ident. If you ask someone who has no idea about programming, they can name a programming language. There's a high chance they will name C++ or Python. Like in movies, TV shows? I don't know. Last time I remember a mention of a programming language in a movie. It was actually Rust. There was some Rust on the screen in some movie. I don't remember which movie though. But also, I guess the reason I know about it is because I'm following like some Rust stuff. Oh, we need to actually have like the this stuff, right? Int 32 in 64 float 64. So this would be what? Int 32t in 64t double. Wait, is there like a specific C double? Is there a more precise thing? And go to the definition too. There's the long double. I think long double is like 80 beats, right? I don't know if like the double is guaranteed. I mean, I think double is guaranteed to be 64 bits, right? But the long double is probably not guaranteed, but I'm not sure. What do I not have? Void named. What do I not have? My error messages are not that good right now. Void named char. Boolean. Yeah, I forgot the boolean here. Expression is not a unit. Right. So over here, when we're trying to apply a function, what actually happens, right? We need to calculate f. This gives me the identifier in which the f is stored. Wait, can you actually wait? Hold on. Can you even do this in? I mean, you can, right? You can store the function pointer in a variable. But I feel like we don't want to do that. Right? Wait, can you actually do that in C? Can you say over here that like, and how do you like specify this? Int star? Is that how you do it? Main2 is equal to main? No, that's not how you do it. Or do you need to like void inside? Hold on. C function pointer. You need to first do a type def, right? And only then you can do it. Yeah. I think that it means that I don't store this in an identifier, right? Because like this function over here is going to be right. Let's have something that's called like a pure expression. Pure. Which is going to be I'm just going to say pure expression, which is an the expression, you know? So this returns the pure expression, is what I mean. Right? Yeah. So over here, when we have the identifier, well, I mean, yeah, yeah, the function, if it's not actually calculated, we would be able to like return it over here somewhere when we're claiming the thing, which is an identifier. I don't know, maybe we could still do the identifier. Anyway, so I want to have the expression, which is apply function and args, right? So there's like these args is new for arg in iterate over those args. We say args back arg. Arg is what? This should be just expression, right? So we say calculate the argument, but this stores it in the identifier, so we just push back the expression, which is identifier arg, right? Okay, so what are the other things? I believe we will need a statement expression, in which case we just calculate this expression and we don't care about the result, right? Statement, so this like returns a void, so we don't store this in a variable, right? So yeah, statement expression, and we just calculate the expression, and I just yeah, and then we don't have the identifier technically, right? Yeah, we don't have the identifier then, so we need something more typed here. Maybe I do return pure, right? Because pure will have the expression, which is going to be like an optional. It's the expression then. Maybe like this is what I want in general. So in this case, we will return expression is some identifier, you know. So assign it to a variable, right? But we don't do it if yeah. How about this? We calculate this expression. So this is a pure expression, basically, that we have here. Wait, is this pure? No. This is just expression. It's not necessarily pure. Right. Which is why we assign it to a variable after all. Okay, let's just do this. It's okay. But in case of a statement, this is not what we return. We just return... We don't return a unit here, because that's impossible. So we instead return the return void. How about this? Return void. And we have the function void, which returns the pure expression, which is expression is none. There we go. That. Just return void. So here we have the function. This is the result, right? And we are only going to insert the statement to return the result if we actually have it there, right? Because this is the pure expression, which is optionally have the thing, and it is none for the void return, and we don't even insert the returns, right? So if result expression is some expression, then we insert the statement to return this expression. There we go. I don't think I stream for very long today, so as soon as my hello world from minicast to C is working, which we still need to do like the native expression at least, and like fix these errors, of course. Type identifier expression. Oh, it's not expression, it's a value, right? Yeah, it's a value is expression. Which we just call this value here, right? There is a 0-day market that actually has been quite active since vibe coding became some common actually. I thought I heard that like the new AI from the Anthropic or something is like finding the exploits and like vulnerabilities in the things that are not vibe coded but are there for a long time. Is that true? Or is that just like their marketing strategy for the upcoming thing? Did they really call it type instead of tie? Most of the new exploits are because vibe coded stuff has become common. Yeah, that's not like surprising. Well, I mean, the other one is technically also not very surprising. Absolutely could use AI to find exploits, but you need to prompt it to talk about low-level stuff. They lie more than anything, so you cannot trust them. Yeah. Hello? Well, it will be hard to find 0 days in Kast because LLMs aren't trained on it. Well, I did not. I don't like use AI mostly, right? But one thing that AI could do before already is it could transpile Kast to JavaScript. That already happened with no help. So I feel like it's um, it can understand the code. In general, like the programming language is kind of irrelevant unless it actually brings some new feature, some new like semantics, right? Which I technically I don't really bring much new semantics. We just like combine the existing semantics of a bunch of different languages together, right? I don't really invent anything new here. And so I think the syntax is not the obstacle for the LLMs, is it? It's just the humans that for some reason they look at certain languages and like, ooh, that doesn't have that like has semicolons, and I like my Python syntax. I'm not going to even look at this. But the machine, it like, it's whatever, right? You're investing in a custom front end, huh? That's doing no semicolon over there. Transpiling to JS means that you have a bridge, but it doesn't open any 0 days. You can try it. Give some examples in Kast. The LLMs translate some C code to Kast. Yeah, I don't think it would work like to create like, but like you don't need to be able to create the code in this language to understand the meaning of it. That's what I'm saying, right? You can read code without being able to write code. I feel like reading is easier mostly. No? F is pure F. There you go. So right, because like calculate returns the pure thing, and this over here returns the pure thing. So we need to say like pure argument. Maybe like we say calculate and we say like pure calculate. You know, pure calculate arg. And then I say this, right? So like pure is a function that takes the pure thing and returns the AST expression, which technically just says that like we just match expression pure expression on not convert don't have or I don't know, pure expression is pure doesn't have expression. It basically means that we were trying to do the void star, to do the void, which we don't do. You try to read your language, however, because Korea is based on regions, linear types, routines, etc., it really trips up the LLMs. Do the LLMs like do they still write like Rust code well? I mean, do they write it well at this point? Because I think they were not very good at like satisfying the borrow checker. What is this? It says the reference is not an expression. Because of this expression. Yes, this is a different expression, right? This is I want the original expression, kind of. So that I can have its type. Let's do this. Field tie is not there. Are we compiling to see for faster bootstrapping? Well, no. The goal with C mostly is, well, we'll see. Maybe I do finish it, but the goal is to understand what are the features that I need in minicast, so that we transpile the cast to minicast and we compile minicast to C, JavaScript, and I was thinking Golang, right? But maybe we can keep it C, right? If I just don't want to be constantly debugging undefined behavior. But there are things like field C, so maybe we can do that instead of doing the Go backend. Just keep Golang instead. Yeah, but like Golang, I mean, yeah, I just don't want to do like too much work. Like I said, we can like technically, if we go like to the targets immediately, then we would skip the C2, right? And we don't go to the WebAssembly. We go LLVM directly because that's like the final goal anyway, right? Kind of. So I should have skipped JavaScript, right? Like, but if we want something working as soon as possible, then I believe that starting with JavaScript is the correct way to do it. And then Golang is somewhere in between of C and JavaScript, basically. C has an advantage over LLVM. The advantage is that it has more targets that you can like target, or what? Or is there any other? Just more targets. Yeah. Okay, we want the new block. This is simple. How many people will use Kast? Will embedded people use Kast? I don't know if anyone will use Kast, but I'm making it for myself. I just like the idea of being able to act like I mean, realistically, I don't like if I just think about myself, I don't care that much about the low level details, and like the speed of JavaScript would be good enough for me, I would say. But I do like the idea of like the zero cost abstractions and being able to have both a high level and a low level language at the same time. But even although I would only need the high level, I only really care. I care a lot more about the high level aspect of the language, right? And like since we are designing it this way, like it's in theory supposed to be fast language, right? I mean, I am just doing the JavaScript for now, yes, but my JavaScript that I generate is also like very inefficient, and there is a problem with generating efficient JavaScript. So generating efficiency is actually kind of easier because like right now I'm doing this async stuff, and like async brings the problems. But in C, I like at least like the programs that I have written so far, they technically don't need async, and the only reason we use async is because the APIs which are sync in C are going to be async in JavaScript. But because of that, I'm converting everything to be async currently, which is a lot of overhead. And I don't want to introduce the async, the design wise. I don't want the async to be something that I think about much as the user of the language. Like we're supposed to, I don't know how to say it, but like you don't think about your Golang code as being async, really, right? You just pretend it to be sync code, but it is all coroutines behind the scenes, right? But you cannot do that in C because you cannot do like the same in JavaScript and make everything async, because in JavaScript there is a lot of overhead. In Golang there is not a lot of overhead, which is another reason why I was considering Golang as like the middle ground, right? I mean, I will need the async eventually. I will want to have delimited continuations specifically. And like I could just implement them using async in JavaScript. In C, I would need the continuation passing style rewrite or something. Or do fibers is another as another option, I suppose. You don't have non-blocking async either, because it requires at runtime. And you're aiming for something lower than C. Yes. Well, I'm aiming. No, I'm not aiming for something lower than C. I'm aiming for something that can abstract over, like, multiple targets, and like that is not that easy. I think it would be actually easier to make Kast if I was only like targeting like the low level stuff. In certain ways, it would be easier. Right? Like, how do you abstract over JavaScript and C at the same time? I see block is not unit. Yes, it's not. Wait, what? Oh, because body over here is a unit. Yeah, this body over here. Yeah, I need to return the block. There we go. What is this now? Array list is not a program. When you say result functions. Regions are there to abstract away allocation instead of some global malloc free. Right. Okay, some of this context-related stuff is actually not correct, but it's okay. It's going to work right now while I'm targeting JavaScript, and then we will debug this thing eventually. If you want to change allocation, then you just use C with no stdlib. You're writing a kernel. There's no libc there. Yeah. Yeah, I would like to try go into that direction too. I don't want to like do like the only issue is that like if I try go into that direction, then like I don't want to do it for too long, you know? To like start writing my own operating system and shit. Like that's a slippery slope, you know? You start. I mean, yeah, we've been on the slippery slope for a long time. First, like the custom game engine. Now we have the programming language. Next, it's going to be the text editor and the operating system, right? This is not array list. This is ORD map. What's regions? Well, I would assume that regions is basically the lifetimes, but maybe they mean something else. That's usually what it's called in languages. But yeah, that would not make sense that you are abstracting over the malloc with it. Probably region means something else. Region probably means that you have you are allocating the memory somehow, but like the specifics of how you allocate. But no, it is lifetimes, right? Yeah. Pattern mention on exhaustive over here. All right, because we want to compile the then. Wait, what do I want to compile the then? Oh, right, because we have this, right? We have a native expression, and then and this one we will just use for the inclusion of this stdio. Right. So we want to have then expressions. We just say for expression in expressions iterate. We calculate expression, and then we say that this is like the result is option is like none, I guess. And then over here we say result is sum, calculate expression, and no, result is equal to calculate expression. Over here we say, so we say by default it is void, but then over here we calculate expression and we just return the result here because we don't need to assign to a variable. This is already like doing the thing. Yep, okay, I do like this. And then we will have the native expression. So let's do the native expression immediately. Native expression means that we have the parts there. Native expression. Native expression has parts, which is either a raw or interpolated expression, basically, right? Yeah. Native parts. If you have a struct S with field F, the F's region is the region of the struct S if it's sound, right? Um, I think there was like some proposal to or like some talk about Rust region versus lifetime, and there was something. I mean, lifetimes are named regions. That's what's the Rustonomicon sense. Regions of code. I don't know. I feel like I don't actually understand the difference between the two terms. Rust does really have heap regions, at least not dynamic ones. Heap regions. Yeah, I guess. The lifetimes are static, indeed, in Rust. Although sometimes maybe you want it to be dynamic. I wonder what it would look like. Do you have an example in your language? Where it would have to be dynamic region. So what, you store the region variable actually in the variable? You have like linear keys for them. Well, I mean, I don't know. I never looked at Cyclone. Maybe I should. That sounds like something that is useful to look into. Hmm. Let's see here. So we need actually the like the raw expression in CAST, right? So we need to have an expression which is raw. That would be like just string, and then we have the raw parts. And let's have a list of expressions. There we go. Same how I did it in JavaScript. So when we print the expression, if this is raw, just write as, right? Maybe we should like detect the raw expression somehow. Let's do ANSI with mode cyan, for example. If we have raw parts, let's do print raws. We have raw parts, if part is raw, then print raws. Otherwise, we print expression part. And the reason we do this is because we don't want to do it with parentheses in the raw parts. Right. And when I print raw, something like this. Okay. And then when I transpile here, we have raw as this. So we will create the raw parts, right? So result parts this, that mutable. I will turn the expression which is raw parts. Maybe we could call it raw parts. Your input system finally works. You thought he was going crazy. Mm-hmm. Okay, and now like the thing that we need to do here is we need to detect the includes, right? Yep. I feel like yeah, I don't know. We can say like, let's just do this. If as strings strip prefix of s prefix is the include, like this is some include, you know, then I will return void after all. And I will say that context result includes wait, hold on. And what I want, by the way, in the includes, I feel like this should be the ord set. Do we have the ord set iter? We do. So yeah, because I like, in case we have in case multiple things request the same include, we should include them only once. I guess it doesn't like really matter, because usually in C they have like the if def stuff, but so you actually include the thing only once. But let's not generate a bunch of includes at the same thing, and so which means that the program includes is a set of strings. The includes, add, include, right? And that's all. And then we return void, then is there, native is there. Maybe we can do the hello world already, I'm not sure. Ord set is not in scope, of course. Use std collections ord set, and to do it both here and in the CST. By the way, you did actually work on a language that has quite a bit of users, not too many, but enough to be considered useful. It's even on version 5 now, lol. OCaml 5. I know one language that's version 5 right now. No Juniper for Arduino. It's a function reactive programming. Right. Couldn't find context. Let's say context is current context. I need to mutate it. So I think like the way this works right now, and I will need to change it. Because kind of like this over here is a like, yeah, I'm like copying the value of the context over here, but I want to have the reference here because I'm mutating the context, right? You know what I'm thinking of sometimes, but I don't think about it too much, is the way C++ does references, right? So, you know, um, we could have something similar, right? Because references in C++, they are not just pointers, right? You basically, because you use them as if you like, I don't know, you use them as if the as you're owning the value, basically, right? And sometimes I kind of want that, right? Basically create an alias to an existing place is what it means, right? Because in order to create an alias to an existing place, the only way to store that in a variable is to have a pointer, or like what a reference is in Rust, right? But a reference in C++ is different. They don't even have to be pointer-like. Well, yeah, I mean, if you're aliasing the existing thing, you don't even need to store it in a variable, right? It's basically like an alias to the existing place. That's what it is, right? And you don't need to go through a pointer interaction to get there. You just get the original thing directly. If you still like have it in your current scope, I suppose, right? But when you like have it as a, or do you mean that they are also not always have to be pointer like when they are even like arguments of the functions? Well, I mean, you can like compile it because like maybe sometimes if it's a reference to some small thing, because it's like faster to clone this small thing than to go through in the interaction of the pointer. So this makes it so that the compiler can choose to pass the value by the reference or by pointer or by value actually. But yeah, it's just a getter setter pair. That's literally what I'm converting my references into in C++. When I'm transpiling to JavaScript, yes, it's a getter setter pair. I think I even have it like over here. Like, look at this JavaScript. I call it place, not the reference, right? But yeah, it's a getter setter pair. And sometimes we convert it into an actual getter setter object in JavaScript too. But I guess in C, the getter setter is just a pointer. Um, Pattern match non-exhaustive over here. We want the scope, right? Because we want something with, yeah. The scope is easy. Hold on, scope expression. I just need to make sure that we have a new scope. Scope is so we extend the current scope. I will add like the context here later, but for now, let's actually do this explicitly then, right? So when we have the block is just current scope block, but the other field we'll see the completion error once I edit. And then we just like we just return calculate expression here. Yeah. Current find block in scope. No, not current scope. Current scope. That's different. Scope ref expression. Semicolon is not needed. All right, it's going to work, right? Right? Oh, look at this. Include stdio void main void value 0 is printf. Wait, does printf return the things? I feel like this is not correct C code, right? Yeah, you cannot have the thing as type void, of course. So this is where we need to say over here, right? Basically, we have this expression which we use to calculate the things. We don't store it in a variable if the type here is void. Is the thing, right? And also if this returns the like nothing to calculate. I mean, is there something to calculate or is there nothing to calculate, right? That's the question. Well, this returns the expression, so yeah. Yeah, I need to say this. If expression type is unit, which is the void, basically, right? Then we do one thing. Otherwise, we do this thing, right? So if the result is unit, we still need to like do this for the sake of the side effects. But then we return then we return the void, right? But we need to insert statement, and the statement is the expression, which is the expression that we need to do for the sake of the side effect, right? We're just calling the function in this case. Right. Unit is the superior void. Well, I mean, a C doesn't have zero-sized types, right? Which is why it has to do the void instead of unit. As far as I know, C does not. C zero-sized type is not a thing. True zero-sized types do not exist. Although you have zero-length arrays, can you return a zero-length array from a function, and that would actually like basically be a void function? And this is the GCC Clang extension, so it's like not. Yeah, the size of will actually return 0. A struct with no fields, which is treated as zero-sized. It's not, I'm pretty sure. Let's try though. Let's try to do the C here. Type def struct empty foo. Right? Let's get rid of all of this other code, which is useless. Right? Let's just say over here printf and the size of right. What is it, like LD? Oh, I actually did the main C. Okay. Whatever. Oh wait, it is 0. Is it actually 0 though? Was I lied to? VDC standard requires that every complete object have a size of at least 1 byte to ensure that every variable has a unique address. Or is this because I'm using Clang, actually? If I do GCC, but it's still 1. Like, is this over here a lie? Or is that like the old information? Because you need to ensure that it has a unique address, right? How do you ensure that then? Let's say that we have the let's say that we have like foo star array, right? Which is like, I don't know. Can you initialize the arrays like this? Wait, my language server stops working. Please attach the following files to the bug report. Did I just... wait, what? Hold on. The clang sec faulted? What did I just do? What the hell? What do I do GCC here? Okay, GCC actually works. But clang actually sec faults when seeing this code. Amazing. Okay. Do I have a statement which is an expression? Yeah, we do. Okay, good. Structural and textual things, they're just something on the stack. Are they? Well, I mean, you can like, how do you allocate an array of 0 size structs, right? Or, well, I mean, are you supposed then to like basically not call into the malloc? And like, what is this? Right? I mean, this is the output of the AI, which maybe means that it's like incorrect. But I was like kind of sure that they do not have proper 0 size types. According to C++ standard, empty structs have a non-zero size nevertheless. So, but this is from 14 years ago, right? Stack Overflow, right? So this is like, there's the empty base optimization though. So is this like the new stuff where they actually added the 0 sized things? How do you allocate such a thing? Well, as far as I understand, in Rust there is literally an if. It's not. It doesn't even have to be a null because you will never like dereference the things there. It can be literally like an initialized pointer because you're never supposed to read that data behind the pointer anyway. But yeah, I guess you just do a null there. C23, it calls calloc on this struct. But before that, it's just garbage. What's calloc, by the way? Because I used the malloc and the alloc A. But what's the calloc? Is for dynamic memory allocation that reserves a specified number of objects. It initializes L bits to 0 and returns a pointer to the memory. Yeah. Calloc is for arrays. So you are actually supposed to do the calloc instead of malloc? Really? What's the difference? Is it undefined behavior if I allocate my arrays with malloc? It's number of elements and size instead of just the bytes. But it also ensures zero initialization. Like this is overhead. Why would we want this? I guess it's because it's faster to do this, because this is a single like, is it a syscall? I guess, right? Because that's just like a single call instead of like two calls to malloc and then mem set 20. Yeah, but getting garbage with malloc is okay. That's what we want. Most of the time, I think. No? Well, unless you're debugging your application, of course. Then you don't want garbage. No, I understand. Yes, it's undefined behavior. But if you want to like initialize the values actually to some proper values, right? Then you would have double initialization, which is hurting performance then. So you don't want that, right? Okay, let's see. So is this correct now, right? We just have printf hello world, void main. It's a void main though, right? Do we have to do it to be the int main? I feel like it has to be the int main, right? But that's like just what we convert in the minicast, maybe? Or is it like C specific? I feel like it's C specific, maybe. Do you think that it should be like the feature of minicast that the main returns an integer? Or do we instead do an explicit sys exit? Is there something that's going to happen in C after main exits? There is not, right? And there is no live before main either. Or is there? Is there? Zeros actually run underscore starts, which starts main. In Linux, entry point is start, not main. What about the exit, though? Is there something that's going to run in the exit? I know that in Rust there is a crate which is called it's called like inventory, maybe, right? And this uses the feature. Maybe not the inventory. Like this is based on something. Maybe it's called Ktor. Global constructor destructor functions. Provides modular initialization teardown functions like attribute constructor in C++. So it's like, what is this? And there's also like the destructor. Is that the code that's supposed to run after your main exits somehow? You guys know about these things? What's the specification of it? Is a compiler extension that allows a function to execute automatically before main function begins. But it basically like injects the code into it, right? And what about the destructor? Is often paired with attribute main, which executes after main returns or when exit is called. So like even if exit is called, it's going to be called, right? Yeah. And you also have the at exit. And then you don't need the extension probably, right? At exit is a module in Python. At exit is also existing in C though, right? Registers a function pointer to be like a written to be called an exit. Right. Why was I asking about this? It just means that I can wait, because this is still like calling an exit. Even if I do the exit explicitly, right? These functions will still be called. Wait, what happens if you call exit inside of the function registered to be run at exit? Is it going to be a trap or something? Calling exit in at exit. Leads to undefined behavior. Of course, that makes sense. Explicit state that calling exit more than once results in undefined behavior. Right. Makes sense. So what I'm saying is that, you know, we like I feel like the main should actually be the stuff that returns nothing. But if we want to return it with exit code non-zero, we would basically explicitly say exit. We would explicitly say exit basically, and the main function would always be returning 0, right? That's what I'm thinking. Because like we don't actually return an integer in like Java's. Correct. I guess we could like inject something that like in the end is looking at the code. If it's not 0, then we like exit. But also this, yeah, whatever. I think we don't need this in minicast, right? And then we can have a main which is a returning void instead, the nothing, and that's okay. It just means that main is a little bit special when I'm compiling here, right? So we're gonna have a function, and I will actually just, so I will literally just return 0, right? I will literally just return 0 if name is equal to main. Return literal integer 0, right? And the type of the function in this case is going to actually be the void, the int, right? And people say C is low level when it's doing all this magic. Yeah. So result type is, how about this? If name is main, then this, otherwise that, right? Also, like if name is main, then I want to like say that if definition result type is unit, then it's going to be this. Otherwise, we're going to panic. Main must return unit, right? And over here we say that result type is actually int. What's this operator? This is dereferencing instead of star, instead of a prefix star. Why does the screen shake when you type? Because I type very, like, I hit my keyboard really hard. That's why. Is that from Odin? I think I came up with it before seeing Odin, but yes, I don't know if other languages do that. There's Odin, and maybe some, I don't know if anyone else is using this actually. Okay, there we go. There we go. Int main returns 0, right? hello world. Now this is like just a bunch of native stuff. So yeah, can we do something better? Can we say like over here? Let's say how about we do the Fibonacci actually? Fibonacci 10 is equal to %d slash n is what we want. Wait, do I do the string? No, we did not. So let's inline this here. But I don't want to inline like the actual Fibonacci, right? So we want to say over here, Fibonacci 10. How about this? Can we do this? Const fib is a function which takes an int and returns an int. And this will be... Oh wait, but then I need the thing. I need the if. I did not do the if yet. Fine, we'll do the if. If is not that difficult, is it? Well, and then we need to do like the other things too. Well, this is literally what the test was doing in the here, right? Here's my Fibonacci. We have the plus, minus, less Fibonacci. We just need to make the ifs, right? Doesn't your operator conflict with the bitwise operator? Yeah, but why are you assuming that I have the bitwise operator? I don't have the bitwise operators at all. I feel like they are unnecessary. I have the functions that allow you to do that in the standard library, but like, I mean, maybe you do the bitwise operators very often when writing low-level code, but I don't know. I basically never use them. So I would use maybe like the other operators which are usually used for this, for other things too. I don't use the shift operators for anything. The vertical bar is used to like define the enums and stuff, right? I don't use the tilde for anything yet. Use shift XOR a lot, but what for? So like my thinking, you also work a lot of on format decoding crypto stuff. Like I feel like this is very low level and similar to how like the unsafe code in C is like gated behind the unsafe keyword. I would basically gate the bitwise operators also. And I mean, one thing that I can do because of the Kast, like of the way syntax in Kast works, is I could like allow these operators to be used in a dedicated sections, right? So like I could say like with bit operators, and over here we would have the expression which actually has the these regular stuffs, you know, because we can have local syntax and like custom syntax and all of these things. What happens when you add two I32s? Regular math operators are unsafe too, though. What happens when you add two I32s? So right now it is literally undefined behavior in Kast, but I will want to make this customizable. My plan is to do this thing over here. So I have like this context system which I use, right? But basically you are supposed to like customize the behavior, where you say what behavior you want on the overflows. I think the default should not be the undefined behavior. It should be like probably the I don't know. I don't know which way I would want to have to be the default, the panicking one or the wrapping one. But yeah. The idea is to have the compile time context stuff, which I already have, but I don't do it for the maths because this is a little bit kind of special, right? But you're supposed to override a lot of behaviors, right? Like it's similar to how I have the panics, and I technically can catch the panics too. I can override the panic handler locally in certain scopes, and similar to it's literally the effect system. I just call it the context system. It's just it's a little bit more low level. So I split the effect system into the context system plus the continuation stuff, because normally in the algebraic effects, like you start with the you always do the continuation, and then you need to like optimize it away the continuation, right? But we instead make it more explicit whether you need the continuation or not, if that makes sense. So the effect handler is the context, which allows you to capture the continuation, I suppose. But not all effects need continuations to be captured. Some of them just need to do the unwinding, and some of them can just be regular functions. But yeah. So we that's what this is about, right? And some of the and like the way I'm using it right now, most of the time over here, I'm doing the current context. This is basically the state effect, right? Or if you were writing the Haskell, this would be this would be inside of a state monad, I guess. You don't watch the stream for one day, you abandon TypeScript for C. Yes. All right, do we do the Fibonacci or do I go rest? That's the question. That was a good one-day decision to go from TypeScript to C. I don't know. I don't know. Well, I mean, right now the way this works is, as you can see, by this by this error over here, I'm actually running the JavaScript right now. So this code that I'm writing, this all is being transpiled to JavaScript, which is then used to generate C. And if I was starting with C, I would get to this point a lot later, I feel like. So yeah, the bootstrap is transpiling to JavaScript. And it looks like this. And there's a lot of asyncs and awaits. JavaScript is so powerful, it made Clang seek fault. Never seen that. I didn't even do anything. No, I mean this over here. I sec faulted the Clang myself without the usage of TypeScript or JavaScript. Which one actually like sec faults? Just like me trying to, yeah, just me trying to initialize this thing, right? It's not the definition of the empty struct, right? It's this expression over here specifically somehow. Like if you do like initialize at least one. Wait, this one works. Oh, because too many braces around scalar initializer. Wait, what? Hold on. This means something different than this? Wait, what? What does this mean? Hold on. what is the meaning of the syntax actually? One is array, other is a block. Oh, because this one is like a block and inside of... Wait, hold on. I thought the block cannot be like on the right-hand side of an equal sign. You would have to... Like, block is a statement is what I thought. Is that not the case? No, this is a scalar initializer. It's not a block. Or is it a block around the scalar initializer? No, that's not it. Wait, what is this? Yeah, as soon as I do 2, we have the segfault, though. In the clang. Let's just do... let's do hello C here. Let me delete this temporarily. We just do the hello world. Like this. Hello C. And this is what we want next, the Fibonacci. Alright, it should not be that difficult, right? So we have like a claiming of the place. In this case, I need to just say calculate place. Calculate place dot get, right? That's what we want. And we want to have, so we want to specify what a place is, which is going to be similar to JavaScript, where we say that we have the get, which is a function that returns the expression, and we have the should this be expression? Should this just be a pure expression? If you use GCC, you can use blocks and parents. What would that mean, though? Is that the same as like you just run some random code in a block while doing the expression? So you have like statements embedded into expressions that way? Here's the place expressions that we have. So the only thing that we need kind of is probably just the identifier name, right? So this would just be get is we return I don't think we need to like make the distinction, like I said, for this in C, for the L values versus R values when we generate the code, right? We just create the expression, which is the identifier here. Which is the identifier name. Okay. And set is value into so now here's where we insert the statement. We need to assign assignee is identifier name and value is value, right? Okay. The fields, indexes, current context, those things can be done later. The temporary expression. Means that we just calculate the expression. And well, I should not be able to set it, I think, right? I don't know, let's try to say that let value, I guess. Let's calculate expression, and then I say get is value, and set is panic cannot assign to temp expression. I will like allow to calculate the reference to it. Actually, wait, can you do it in C even? Can you do in C the reference of the thing? I think you cannot, right? Can you say reference to 2 plus 2? You know? I think you cannot, right? You must store it in a variable first in C. Let's comment this. Can I take the address of the R value of type int? Yeah, that's right. Yeah. You cannot. Which probably makes sense. But this over here is pure, which means that we will be able to actually have the reference to it already, because like we actually stored in a variable while doing the calculation here. You need to place in to take a reference. Yeah. You can do it in Rust though, but in Rust it basically extends this temporary lifetime to like this thing basically automatically creates the place which lives for the duration of the statement in Rust. Okay, these things we can leave it to do. Is that all that I need? Well, we will need the if, I guess. That's the big one. And then I need to have the assign in the here in the statement. Have assign. We'll just have the assign. It should be the expression though here for simplicity. Value is also expression then, right? And when I print the statement, assign assigning is ref assigning value ref value print expression assigning right equal expression value. I hate how I never get my cast code first try somehow. I'm really bad at cast. It's because because this needs to be around. And my error messages are also bad, but it's okay. Glitch, please get this should be a return. What happened to the camera? My webcam fell down. Not having the same syntax for accessing the value by value or by reference is just error prone. Wait, not having the same syntax for accessing by value or by reference is just error prone. Not having the same syntax is error prone. Having the same syntax is not error prone. So you're saying that if there is the same syntax, which can mean two different things, then this is less error prone than having in Rust you just access with a dot. Well, I mean, it is similar issues here, I suppose. Yes. In this specific case, though, it's because of a different one. This over here is required because I don't have the feature of Rust, which is called match ergonomics, where but this is how the old Rust looked like. If you have never seen that, this is from the old Rust, where if you want to capture in pattern matching the value by reference, you need the reference key, the ref keyword. When you do like the dot, and then you can skip the dereferencing though in Rust because Rust has the auto deref. But yeah, it does not matter if the function takes a ref or copied value. No, it does matter. That's true only if your type implements the ref. No. Well, I mean, no. I mean, these are just references, right? References is the built-in type which implements the ref. But you can do it for your own type too. Actually, I'm not sure if it works with deref. If the match, I think I'm not sure if the match ergonomics works with the deref. It's probably only hard-coded working with actual references, if I was to guess. Not with like the smart pointers. The dot syntax though does work for custom smart pointers. pure is not raw parts. Well, over here it thinks that this should return the pure expression, but why does it think that? That's the question. Maybe it's because it thinks over here that calculate. No, calculate returns the pure expression, right? Something is wrong here. If I don't do this, do you compile? Oh wait, it was compiling. Hold on, it was already compiling. Now I'm recompiling for no reason. I was looking at the old error message. I should probably like clear the screen or something, so I don't like look into the old error messages. Now I need to recompile again. Yeah, eventually we will have all of these features. I'm pretty sure I need the auto dereference. Otherwise, yeah, this is a little bit of a pain. I also don't have the automatic reborrowing, which is the thing that Rust has, which means that if I have a mutable reference to a thing and then I need to pass it to a function that expects a reference, which is not mutable, then I need to reborrow explicitly, which leads to code like, you know, reference to X and then dereference like this, right? So like in Rust, this would be like reference to star X, right? So Rust is actually doing this automatically sometimes too. Yeah, and now we have the if. Okay. Let's see the if. If. Let's have if somewhere. If we have condition, then case and else case, right? Okay. So that would be a statement in C. That's not an expression. Well, I mean, we can like convert it to expression, which is like the ternary one, but we cannot do that with the ones that do the units. We do the same. If condition expression, then case is a block, else case is an optional block. If the condition, then case, else case. We write keyword if, when we write opening bracket, parentheses, right? Then we print expression condition. We'll rewrite this code automatically once I do the syntax. I'm just being lazy for some reason to not introduce the shorthand syntax here. Expression condition, then we write the closing bracket, space, then we print block, which is the then case. Then we say that if else case is some else case, then we will write a keyword else and we print block else case, right? If else case is some ref else case, we also need to do this because there's a reference to option. Okay. And then here we need to convert it, right? So we will have the identifier, new identifier, which is called like the if result. Basically, we will store the value there, right? So we need to first define this variable, right? Yeah, we can like we can, and I guess we must create a variable which does not have the value, right? So the value when we specify the variable is optional, actually, right? So over here we say only if value is some value, only then we print the equal sign. So in this case, value is some value though. When we let var right, or like is it correct to do it in C, like the initializing syntax when you say like int x is equal to this? Is that correct, C? It seems like it is. What does this mean though, exactly? In this case, it doesn't even do any warnings. It means like this actually is the empty initializer list, which is the same as don't initialize anything, right? What's the standard? Is this not the standard thing? The initializer list? I have no idea. I mean, I would like to be as like broad as possible, I suppose. Like, what's the reason to target something more too specific? Right? Are they backward compatible? C89, C99? I see most people are doing the C99. But I don't know what's the difference, actually. I don't know C. I only know it in theory. C99 is probably because of tiny CC aims for C99. Who knows C? Well, I don't know. More people than know C++, I suppose. Okay, so we have this identifier. First of all, we need to figure out the do I even need to this identifier at all, right? So we say this if expression type is unit, then we don't do this, right? Yeah. I don't have the is not, so I need to like is unit and else like this. You know PHP, so you kind of know C. What happens if you print X here? Where? What's X? Are you talking to me? In the C code? Oh, you mean like over here? I would assume this is like not initializing it actually. But we will probably see 0 because like that's the same as saying int x, right? Well, actually, it's not, it seems. No. This actually is the undefined. But this is defined. So it's initializing it to the default value? Is that what it means? Yeah, that's not what I want. I literally want undefined behavior, kind of here. Right. So if it is not unit, then we need to define the variable outside of the if, and then inside of the if, in the final, like, as the final, like, statement of the of both blocks. I would need to do the things, yes. So yeah, first we say insert statement, let var type is var type expression type value is none. Identifier. Right. So we do this. And then how about we do this? Let is void is, I actually cannot, I don't have like this as like the expression. I only have this as a dedicated syntax and the if. So we can say if this is unit, then true, else false. That's okay. If not is void, then we do this. Then we insert this statement. Okay. Yeah, so we return the yeah, I will return here, by the way, the expression, which is some identifier ident. It's where we have the result. Well, we return if is void, then none else some identifier, right? Okay, but then we need to insert the statement, which is the if statement. Condition is pure calculate condition. So we have this. We have then case, and we have the else case. Let's see. Let's do one line. We'll just say that then case is supposed to be a block, right? With statements, right? Then case. So we do this. Then case is a new block. That's what we have already. Then we just need to enter this block, which means that we need to say that with scope being the block is then case. I need to do this inside of scope myself. So we enter the block, and then we calculate the actual then case, right? Yeah. And then we say, I guess I actually say that if, right, I say that if calculate expression is some expression, it's some like result basically, right? Then I would have to assign, so I'm going to insert the statement, assign, where assign is identifier ident, and you will assign there, because like this also means that it's not void already automatically, so I don't need to check it. And value is result here, right? And same we do with the else case, so we say that else case is else case option. So do we have option as ref? Yeah, we have as ref. That's what we want. Reference to optional reference. Option map. I mean, we can also just do a match. Maybe this is actually clearer. I don't know which one I prefer. Match else case with none, then none. If we have some else case, then but actually I cannot do this, right? Let we need to do this. Let then case to be equal, because I was shadowing my variables here. That's when the block is new block. We return the block and I return the block like this. And we do the same here, right? Block is new block with scoping. Block is my block. And then we say, I mean, I literally say the same thing. Kind of a copy paste it here. But in this case, we calculate the else case. And then we assign to the result this thing. And then I return that. And everything has been done, I think. Right. What are the chances that the Fibonacci is going to work? First try here. I think we also need like to convert the literals though. None or AST block. Hello, elemental magic. Hello, hello. None is not block. I mean, yeah, in this case, we return some block. Right. Kast is really coming along. I have written 14,000 lines of Kast code in this repository, which is the self-hosting repository. And it is not even like self-hosting Kast yet. And my bootstrap is 20,000 lines. Or maybe it's 25 lines of camel. I'm not sure. It's actually, yeah, it's been bigger, right? It's 25,000 lines. So it's like half done basically here. But I have not started working on the actual like Kast. I'm making like this intermediate language. If it becomes something you can use for normal development. I mean, I am using it for some things, right? Yes. There's a bunch of things that have been written in it already, so it can be used. It's not very pleasant to use right now, so I wouldn't recommend it yet, unless you're like really interested in trying new things. But the error messages are horrible. There's some like rough edges. Some things are. I mean, I have not like seen a lot of like. Yeah. I have not like seen too many issues. I'm like aware of some things that I'm like not using actively, but yeah. Or actually, I'm sometimes I'm abusing the things which I should not. Also because they will stop working eventually. It is not as bad as Haskell. The error messages? No, I think it's worse than Haskell right now. I would say that. Yes. I need the literal. I need the literal integer. To be converted here. Right? Yeah. Haskell has some of the best error messages languages, not error messages, syntax. It's so weird and confusing. Okay, do you think that this syntax is weird and confusing? Do you not like my syntax? Would you prefer some different syntax for some things? Or for all of the things? I mean, there are some things that I am planning to change, right? For example, right now I don't have methods, but I will have methods. So this code will actually be written as something like raw parts dot pushback, raw s. I feel like this is what's like the final goal, but right now I don't have the method, so I need to like pipe this into a free function instead. You don't get the vertical colon. Vertical bar is the start of the case. So right in Haskell that would be just the case keyword. Colon is the means that it's a variant. In Haskell, you basically have to name your variants uppercase and variables lowercase. I don't want to make that distinction because I feel like that is worse than like specifying this, and I like it. I feel like this is like weird when you look at it for the first time, but I actually really like it because it like removes the ambiguity, which like which like exists in Rust, for example, and in languages like Haskell and OCaml, the ambiguity is not there because they use the capitalization of the first character for disambiguation, which I think is wrong. This dot parts is ref parts. This is just like I do have the shorthand syntax like this, but only if you like take the pattern match by value. So I probably want like the dot ref here, and I mean eventually we want the match ergonomics like in Rust, where instead you match on the reference, but you don't like have the reference here, right? Which would automatically capture all the fields by reference, basically. That's what Rust is doing. I'm not sure how I feel like about this explicit with return, but this is very like useful, especially when you want to return from the inner closure, which is something that you cannot do in a lot of languages, like Rust. And it becomes very verbose if you want to actually exit the outer function. There's like this syntax which I want to change, but that's okay. This like module being inside of this should probably just be module, but I will change that. Yeah, there are like some things. Do we have something like go to from C? Well, we have unwinding. The building block is the unwinding. There is going to be like two building blocks, which are like these like control flow related ones, which is the unwinding, which is already implemented. With return is the syntax sugar, technically. We have basically named blocks which you can break out of, right? So if you're familiar with Rust, you can do something like, you know, block, and then you like do something inside of this block, and you can like break out of this block with a value. So like we have this, which is done with go-to, I guess, in C, because you cannot have that. But that's what you usually use it for, I think. And then the other building block, which I have not implemented in this rewrite, is the delimited continuation stuff, which is a lot of go-tos across functions and stuff, technically. But yeah. I was doing the literals, right? Also, Kast Mami. Kast Mami is a thing. So much documentation. Amazing. Kast index looks okay to you so far? Yeah. I mean, I'm open to suggestions of how to improve it though, but like, I have changed some things already. I do plan to change like some small things, which I was just talking about. But in general, I think it's pretty good, I would say, in my opinion. But if you see it for the first time, as like a C developer, I can see how you just turn away. A bunch of FFIs already defines you can just program in natively without defining all the glue yourself. Well, I mean, I do have this this standard library, right? Is the semicolon option when returning from a function optional or what? Oh, this yeah, I actually like this is a little bit weird here, right? So the problem is that the return, right? So I don't have the semicolon over here, and that is because it has to do with the type inference here, right? What's the result of this expression, right? So if I do the semicolon, then it infers the result of this to be unit, which is not correct, right? And if we do this, then it can be anything, because this is basically supposed to have the never type, but right now I don't really have the never type. So instead we have the polymorphic type here. So if I do the semicolon, it doesn't type check, but without it, it does. And I guess the way it does work in Rust is that the never type automatically propagates if it's like the last statement. Yeah. Well, the return is not needed, right? If something is the last thing in the function, that it returns automatically because it's an expression-based language. Return, by the way, it doesn't return from a function. It returns from the return block, and you can define this return block anywhere. It doesn't have to be on top of a function. Right. So like there's no returns over here, but we do return things. And semicolon just means that it's a unit. I don't know. I don't know if I want to support actually the semicolon here. Like sometimes I feel like I have too many semicolons compared to Rust, but I feel like it is actually a lot more clear than the Rust sometimes, right? Because in Rust you have the if, which is sometimes is treated as statement, and sometimes is treated as an expression. So in Rust, the semicolon after like the curly brackets is optional. And I think the formatter also deletes them. But like, I don't know, it's weird in Rust. A little bit. So this makes it obvious, in my opinion. Isn't return block just a function? No. No. Return is basically like a jump, right? It's a go to the end of function, and like well in your normal language where return returns from a function, right? But why does it have to return to from the function? We can return from anything. I can show something. Let me see. Let me see something funny somewhere. Maybe in the parser somewhere. Maybe like with diagnostics unbindable handler somewhere. Oh, look at this over here. Maybe. I mean, in this case, it's not a return, but a continue. But I'm continuing this loop over here from inside of a closure, which is going to be called inside of like these functions in somewhere. I don't know. There's something which is simpler. Oh, this over here. I have the return. So we have, once again, we have a closure. So this is the handler of what happens when we have an error in the lexer, which can happen like inside of like this code basically, right? So whenever it happens over here, I'm returning from this block over here. And this block is not the function, right? So like this is the entire function. And this over here is the block which I'm returning from on the errors, right? And in this case, we're trying to calculate the next token. But in case we see the error, we want to return the error token because we want the error resilience for like the language server and stuff. We don't want to actually panic and exit the program, so we need to catch the errors and like do stuff. A closure is the lump function. Yes, but we are not returning from this function. We are returning from to over here, right? That's what's happening here. I don't return from this function. This function actually never returns, which is why it has this type, which is it's a generic type, which is returning any type. Technically, once I implement the never type, this should like be the one that returns never, either with a keyword or the exclamation mark or whatever we do for it. So we actually don't return from this. We return from this. We return from the outer block, not from this function. There is not a lot of languages that allow you to do this. I know that Kotlin has returned from outer function, but I'm not sure about like the others. Yeah, you have a qualified return, which allows you to return from the outer function in in Kotlin. Let me see here. Right? Yeah, you have a local return to the caller of the lambda. Yeah, so like in this place, you can return to two places. You can return to this, or you can return to the for each, which effectively breaks the loop, if I understand this correctly, right? And you can also make this be a named block by running the closure immediately, which makes the same stuff, I suppose. Yeah, the non-local returns. And I'm combining that with the context stuff pretty often, I guess, mostly to handle the errors. What was I doing? Hold on. See. Oh, I was doing the literals, right? Literals. So if I have a literal, um, literal, calculate, literal. Let's at least do this as a separate function, and let's return here. Calculate literal. Do you like the way you wrote the ifs? This over here. I mean, you mean the implementation of transpiling the ifs? Yeah. Or do you mean like in the language, the if then is readable? Yeah, I like the if. I was like, originally I did not like the fact that I had the then keyword, but then it actually is really nice. And there is and same with the do keyword in the loops. I actually really like this. Right? And the reason for this is that if you have like if with a complex expression, which I mean, like I guess maybe you would like extract it into a variable, but sometimes like how do you name this variable is also an issue. So you could have like an if, and over here you have some like some you have some complex condition like this, which spans multiple lines, right? So then you have like the explicit then keyword over here, which is very nice, same like as else, you know. And if you don't have this keyword, which is what you don't in multiple languages, you just have the brackets, which I don't know. It is less obvious that it's the end of the condition in that case. Okay, here's all the literals that we have. So I want the ast.literal, I think. And then we will return pure expression is some literal bool x int x and 64x. I mean, this is just like all the same stuff, right? We just convert from one type to the other. suppose. Do we have all of these as literals in the AST? Of the C? Int char string. Wait, do you need to like suffix the long, the like the int64s with like L or something in C, right? Can you like say int and yeah, can you have like a literal of a specific type, by the way, right? Because if you say int32t, can you do underscores? You cannot, but you can do this, right? I think. Wait, where's my LSP stuff? Wait, but no, what? This is not correct. Wait, where is N32T? I thought I have it. No? So this is not actually correct syntax? Include std int. Okay, so this is this. What if I do that? So it's a warning. Conversion from long. Oh, wait, hold on. So it automatically made this long. So you don't have to specify the suffix like L or whatever anymore. And this is already automatically long. The other way? What's the other way? Goes from long to... Well, yeah, I mean, like, what I mean is that if you actually want to have a long, you don't need to specify the L, right? So if this is in 64, right, then I don't need to put the L, and this is still going to be the correct one, the correct literal. That's what I get from this error message, right? How do you print the int64 aka long? It's just LD. Long is something different. Okay. Right. This is correct, but this has the L, but this one doesn't, and it still is correct. Is that like part of the C standard, or is it only working in Clang? Why is what's the reason for the L suffix then? Do you need the L suffix for long literals in C? You don't need the L suffix for simple assignments because the compiler automatically assigns the first type from a predefined list that can hold the value. However, you should use the L suffix in the following critical scenarios to avoid bugs, preventing overflow in calculation. Without a suffix, literal treated as an int. Right. All right. Yeah, but we don't do this technically. But yeah, maybe this is still is a good one, right? And what are all of the suffixes? But long int is not necessarily forces literal to be at least. Wait, hold on. Forces the literal to be at least along, at least 64 bits. So you like, it's not like it doesn't force it to be a long. It's at least long, right? Let me just do this for now. I don't have the boolean. Let's just do this for now, and then when it breaks, then we'll see what breaks. If it does. Alright, please, this should be it, right? This should be the Fibonacci numbers. I think. Working. But I ran out of RAM. So let's restart the build. It's a little slow. So we'll have to wait. Let's take a look at this code, maybe. So we define some like things. So in this mini cast, we don't want to have the operators. We only have the functions, so it doesn't really matter, right? This is not supposed to be written by hand anyway, but here's our Fibonacci. If less, and let's do, then we do this. Print f. Do I want to support like the actual var args? Because otherwise, how do I do the print f? I feel like we will not going to have the print f. We're going to have some other like thing where we print things one by one. Right? Like I would have a separate function. Oh wait, I did not compile actually. No. Oh wait, it's because I want to do the unit here. Because I wanted the unit to return the void here. That's all that I wanted to do. C types are confusing. Instead of having normal naming, they decide your dog. I heard you wanted twice as long, so put long after long. Long is mega cursed. What about the long double? What about the long double? Okay, look at this. This is the C code. We have so this is all the definitions of the functions. We have the Fibonacci, we have if result. So over here we have the value 2, which is n is less than 2, right? So if n is less than 2, then the if result is equal to 1. That's what we're going to return eventually. Okay. A bunch of things here for all of the temporary expressions. This looks like it's going to work. Let's see. No! My errors, what's the issue? Oh, it's because that's unknown type. Okay, so because I'm actually generating this thing, we need this, what, std int? It was std int that I need, right? For the type definitions of the int32t. Right. I guess since this is part of that, we need like the includes. Let's say like contact includes. We're going to add the std int dot h, right? int32t and stuff. Similar. Context result. You think they added long because of Windows only, but if you three separate words to clear a primitive type, someone needs to go to jail. Yeah. Unknown type name boolean. Wait, what? You don't have booleans in C? Wait, what? Bool? There's no booleans in C? What's this, underscore bool? Need a library for that? C bool. What do I convert it into? Do I say char? I mean, yeah, there are just zeros and ones, right? But what do I use as a type? Is there like a byte? What about the char? Like, we want a byte. Is there like some type that makes more sense? Maybe in std int or something, right? We want like int 8t maybe. To use int for bool, but int is like more in memory. There's std bool in newer versions. Yeah, but like using just int is not efficient. Is it? I mean, it's probably like whatever. std bool bool. Okay. std bool h. Right, it exists. Does it exist like in all of them? Yeah, and it's actually like this underscore bool, I guess. But this is a GNU extension. And there's also like the false and true then, right? Yeah. Okay. Let's just include the std bool. I just added the std int, and there is std bool. Bool is on the standard of the C23. Okay. That's sufficient for storing, but not when using. Yeah. When using, it's just the register, so it's whatever. Yeah. Okay, it's compiled. Look at this. Fibonacci number 10 is 89. Okay. Maybe let's make this a little bit of a nicer code instead of like putting everything into this printf. Like, So I think printf is the function that takes variable amount of arguments. I don't think I want to support that actually. I'm not sure. In the minicast here, but what we can say is we can say that like print print string, which is going to be printing the string specifically. Oh, but then we need the strings to have been administered, right? Yeah, when your C code works, amazing, right? So this would be just native printf percent s s, right? Or is it? Right, the question is what we do with strings. How do we represent the strings? Because that's not that simple. But yeah, I think what we want is like to have print string and then print like int 32, I guess. And this would do the %d, right? So we would instead split this code into things. Like print string Fibonacci 10 is equal, right? And then we print int 32 Fibonacci 10, and then we print string /n, right? Instead of having it like all by one. Is it less efficient to do that in C with like multiple printf? Technically, I don't think it matters like for the performance of the printfs. I mean, I don't think that the performance of the printfs matters much in your usual applications. But and we also don't need to do the printf %s, right? Because this could be f right, right? That's what we were doing previously. Did I remove this code already? Temp C. Right, that's what we want. We want the strings to actually be this content and length, right? So this is what we do, right? We write the content size of char and then as dot length into std out like this, right? So okay, yeah, but s in this case, yeah, because like we don't know that it has this the field actually, I think, in minicast. So this would be a native dot length, I think, dot content, and this would be native as dot length, right? So this means that we would have to have the type definition of a string though. I need it to end. Why am I not ending? I can do this later. Because I have not started doing the types at all yet, right? And this needs to be a custom type. Unless I make the strings to be like the C strings here. But I don't think I want that. Let's comment this out. Let's say instead say native printf Fibonacci 10 is equal to %d Fibonacci 10. There we go. Just to make sure that it works again. There we go. And we want a /n. There we go. Okay. Fibonacci in minicast to see. Right. Okay. That's going to be it for me for today. I think this is good progress, right? So I'll see you guys next time. I'll go to keep it. TCAP.
Grief, Simon.
Oh, TCAP is choosing the rate target also. Let's see who he rates.
Madness. Guys, look at this performance. Is it weep if it's is it weep if it's real people singing it live? It's that one song that you skip when I play. Who you rate? No one yet. I was just looking around, you know.
Alright. Which means that it's safe to rate him. Alright, see you guys next time. Thanks for watching. Bye.